Yes, it was my fault. Hey everybody, my name is Claudio. I'm with Cartesi, one of the sponsors. I want to say a big welcome at this Epic Web3 Layer 2 Day. Thanks for being here. Before we get started, I want to invite Alex on stage to say a few words.
Thanks. Yeah, I just wanted to say thank you everyone for being almost on time. I think we expect more people to come later. This is actually our first event for developers, but definitely not last. I would like to say thank you for Cartesi for making this, helping to make this happen. Also thanks to ConsenSys for supporting us. And also to our community partners, Talent Protocol and Gnosis, who supported this event. And without further ado, let's start. I just wanted to add that we will have a conference, Epic Web3 conference, in June, 9th of June. Cool agenda, check it out on epicweb3.com. More than welcome, everyone. It's for builders, founders, and probably even developers. Yeah. Thanks for having me.
Thanks for having me. We're going to kick off the day with Vitali, and we're going to get a talk about how to choose between different layer 2s. So, Vitali, sorry. I was looking in the audience. There you go.
We're looking for Vitalik Buterin, but it's just me. Hi guys. Thanks for coming. Thanks for organizing it. Thanks for making it. How do we play this presentation? I just need to click something. Thank you. I'm clicking, doesn't work. Yeah, now it works. Alright, so let's start. How to choose an L2 for your next project. You can also build an L2, by the way. You don't necessarily need to choose from the existing ones. There's plenty of them. It's a bit slow. Yeah, so we're gonna first look at the market, look at all the existing L2s out there. Then I'll tell you how to start building on top of any of them. You need to consider several things before you start building whatever, so we'll talk about that. Then we'll talk about product market fit and time to market and the development strategy, all this boring stuff once you raised or something. Then I'll tell you several tricks about how to work with an L2 code team and with any other code team, to be honest. So first I want to introduce myself. I was before crypto I was working in traditional finance and corporate investment banking. Now we're building a Orderbook on Fuel network called Spark, so we're already building on L2. I'll tell you how I'll tell you about our path. Before I was building 2 years on Solana, and I was contributing to the Solana Foundation itself. I built Neon EVM, and I was running a blockchain unit in Raiffeisen Bank. It's the biggest bank in Austria, for those who doesn't know. I was running growth on Manga Markets. It's the biggest perpetual swap DEX on Solana ecosystem. It was 65% of liquidity when they were big. So just in case, okay, I wanna explain that L2 is a layer 2 on Ethereum. Okay, I'm not gonna discuss any other L2s out there like Aurora or Neon EVM on Solana or whatever else is there. We'll just talk ETH today, okay? And the purpose of L2 is to scale Ethereum. It was initially built and designed and invented to scale ETH and all the projects on top of it. But later this task evolved into scaling a certain business value of Ethereum. So this is what we get right now. This is super slow, by the way. I need to click 3 times until it actually works. So we have around 30 L2s on the Ethereum right now. Some of them are EVM based, others are non-EVM based. It doesn't really matter today because if you're a good dev, it doesn't really matter for you what stack to choose. You can know Solidity or you can know Rust. If you know any of those, it's easy to like jump across the chains and across the technologies as well. So one thing you need to know about all the L2s is that let's say Arbitrum 1 and Optimism, they were designed with the purpose to scale EVM solutions. So their business model was pretty straightforward. You just need to like it's scalability, by the way. They have all been designed for scalability. So EVM L2s, they do things faster, cheaper. You pay less gas. You execute more transactions it's a consecutive transaction execution. Others, yeah, by the way, Arbitrum initially they were designed to scale Ethereum DeFi. Right now they deal with other markets as well. So some of these L2s are designed to like just for gaming or for metaverse or sport betting or like NFTs, invent your own business thing. And by the way, there are even inside of those L2s, you can sometimes find like different segmented chains where you can scale whatever. For instance, on Polygon has several ZK EVMs and ZK VMs in general. You can launch different types of privacy stuff on that. I don't know why we need so much privacy, by the way, but it's there. So before you start, you need to, I mean, this is something you should probably know even before you like start building anything in crypto. You need to understand why you're here, what you're intending to build. It can be DeFi, NFT, metaverse, like Web3 gaming, whatever, gambling, sport betting. It's up to you. Like this is financial world. This is financial technology. You can choose whatever you want. Then I think this is also a pretty basic one. You need to understand who are your users. Who are you building it for? This is probably, you need to understand like this audience. Ideally, you should have worked with them before doing anything in crypto, because you can easily serve them in Web2 as well. Now, business model. Again, boring stuff, especially in bull market. Who cares about like making money in crypto, really? I just need to raise a lot of cash, get like shit tons of grants and build on those. Who cares about this stuff, really? But no, in bear market, you need to understand how you're going to make money. I mean, I'm pretty old school in this case. In this particular case, you need to, you know, make it to revenue as soon as possible. You need to build an MVP and start making money. And you need to understand in the beginning, like you need to understand, okay, so I'm launching in 3 months or 6 months or 2 months, whatever. By the way, I recommend launching faster. And then you need to understand how you break even, how you're gonna like make money, and later how you're gonna scale as well. This thing should be scalable. I mean, it's a startup world, right? As well as financial world. So if it doesn't scale, nobody needs it. To be honest, it's like it's a pet project. Then you need to have a team. Yes, please don't try building anything like yourself. You can be a sole founder, but you will end up having a team anyways. And we need to understand what team you need to build this whole thing. It can, by the way, don't need developers. It can be just a marketing product. You can have only biz dev people. You can have just traders and build bots or just strategies. You need to understand what's your team availability, and you need to like consider it when you start. Then this is the last question you need to ask probably. Like, considering all the previous things, you might figure out what your stack can be, what language you should build it on, what technology you should build it on. Like, this is the last question you ask, really. Now, another, like, once you have all those, you will understand what kind of infrastructure you need. This is crucial, because some chains have it, some chains don't have it, but you will end up needing indexers, oracles, wallets, etc., etc. Like, we're talking about DeFi, we're talking about institutional DeFi, but nobody really has financial monitoring, and banks and hedge funds, they're looking at that and they're just laughing. Like, crypto geeks are building something, but they will never come until you will satisfy their compliance process, and it's very traditional. By the way, we have an article about the ecosystems and the infrastructure there, so you can scan it and see what is desired for any ecosystem to have to be like to provide solid developer experience to everyone. Now, if we're building DeFi, for instance, thing number one, the most important thing like that you need to mind, if it's not there, you should bring it. It's your foremost goal. It's liquidity. You need to bring liquidity. It's like blood. It's still fintech, and without liquidity, it's really nothing. Community is super crucial. Community is like 70 and more than 70% probably in this industry. This is what we're building here. Is actually it's not. I mean, in fintech, software is probably like 30% important. The rest is your community. Community are your investors, are those people who market you as well. This is a very strong force, and you need to build it from day one, and you need to understand how it works, and you need to scale it as well. Now, the next one is VC scene. At some point, you will end up raising probably. If you build something and it makes money and the tech works, you will probably go raise to scale this whole thing. And you need to understand what investors are already there. Because it will simplify your raising path a lot. If you go and talk to 250 investors and everyone is skeptical about the tech that you're building and nobody knows your chain, this is going to be really tough for you to raise. So at some point, VC scene becomes important. And ecosystem potential. This will define your valuation. As a founder, you need to consider this, because if you build something that doesn't scale, and if your tokens, if you have a token, or if your shares don't cost a lot, you will just lose interest to this product and you will shift building something else. A lot of founders have done these steps before they understood it, so I've also done these steps before I realized these things. It's fine, like you'll learn through experience, but ecosystem potential is super important. If this is an unknown chain, if you wanna build a big product on an unknown chain, you're probably gonna create this potential yourself, if you can. If you cannot, and if you don't wanna do that, then just choose something where there's a lot of investors and community already. Now, how do you start building on L2? First thing, you need to research. You need to understand what this L2 or even L1, what were they built for? How, like, what's their purpose? What is potential product that you can build on top? For instance, if this L2 has been built for gaming, or it has the reputation of gaming, or the majority of the community is related to gaming, don't try building DeFi there, okay? So this is a gaming chain. Don't set the rules. Don't try to reinvent the rules. Just go with the flow. Avoid the friction. So research and like the tech as well. Research if it even works as well. Now talk to the L2 core team. It sounds pretty obvious, but nobody does that in the majority of cases. Like, go to the event, go to the hackathon, talk to some of the founders of this team. If you feel like, okay, so these are the guys that might like work with, I can work with them, that we align in our like business goals and in our strategy, and again, like there's a human compatibility as well. If you see that, okay, that's somebody I can work with, then it's a good sign. But if not, again, avoid the friction. Tech is important, but actually people are the most important part of life and of any industry as well. So in crypto it's the same. Now I've written it this long to make it super clear. What is L2 best for? What problem was it made to resolve? How does this align to your idea? I kind of already said it before, but I just double down on this. So understand if this is the best environment for you. Like I'll give you real quick. So I was building 2 years on Solana. Okay, I spent 2 years building on Solana, by the way, and I know how this thing works. Like I know its ups and downs. I know it like from inside out as well. And now I'm not building on Solana. Now I'm building on something else, which I will tell you in a second. But again, I'm kind of sharing this because I went through certain steps, right? Like if you wanna serve the like Ethereum community. Of course, you shouldn't build on the EVM compatibility layer, on the EVM composability layer on some other chain. Like this is just basic, okay? Because your community will not be Ethereum community. It's gonna be from that chain. This is just a quick like example. So all these things, again, in the beginning, from what I remember, like John Adler and Nick Dodson, they invented optimistic rollup, like the word optimistic rollup. Then even before that, guys from I think Starkware, they invented a word rollup, like in general. Then ZK Singh guys, they invented this zero knowledge thing, and this is how it kind of began. But later, when something works, you scale it, okay? When something doesn't work, you don't scale. So probably rollups, they started working at certain point, and now look at that. We get all sorts of rollup for all sorts of purposes. Again, like Immutable X was designed for games. Don't build DeFi on Immutable X. But it's kind of, it sounds simple, but actually you can know better what this L2 is for. Like when Sam Bankman came to Solana, nobody knew exactly what Solana can be good for, but Sam Bankman was a very talented trader, and he was like, oh, okay, so that's something I can build an Orderbook on, and I can like parallelize the transactions. It's probably good for order books, but we didn't know what Solana is good for in the beginning. It's you can like discover any chain if you run several pilots, but that's kind of my next point. For instance, I'll tell you real quick. Like we're building, I told you before that we're building an order book on Fuel Network. I'll tell you how to apply the research that I told you before to practice. So what do you need to build an order book? You need several things. First of all, you need to consider latency. Latency needs to be super low. Like Serum latency was 0.4 second, which is great, but Serum had 70% of failed transactions as well. So I thought, alright, so 1 second and 100% of executed transactions would really be the improvement of the situation. Then for the order book, you need to mind gas costs. Ideally, transactions should be free, to be honest, because it's really hard and it's super tiring to calculate those gas fees. If they're free, you just like consider your taker and maker fee and run the strategies on top, so it would really simplify the path. Throughput, extremely important. Some people say 2K is enough for the order book. I would say 10K is the least you have. Now, the next one, you need to avoid data congestions and state bloats. Again, something we failed to do on Solana. Last one, security and liquidity from Ethereum. I thought that, alright, so after Solana, I'm the biggest Ethereum maxi out there. Like, I want Ethereum liquidity, and I will build where the liquidity is and like not anywhere else. So we knew that, we knew all these requirements, and we needed to like make a choice. Okay, so where is this thing possible to build? And there's only one chain really where you can build it in the Ethereum ecosystem. Come on, that's Fuel. We chose Fuel, and for me it was an easy choice because Fuel has parallelization similar to what Solana had, but it finalizes the transactions on ETH. It's UTXO based. I knew that I want to build on the UTXO chain because account model, like in the Solana ecosystem, we're running everything through the contract, and it's not data efficient. By the way, data availability is a huge thing right now. That's why products like Celestia, EigenLayer, Gnosis Chain, they say, are building their data availability layer as well. So they exist because on-chain data is important. Now, Fuel has native account abstraction, but it's kind of what everybody has now. Fuel is modular. You can run it on Cosmos SDK plus Tendermint, but I'm not bullish. I want to stay on ETH. Fuel has its own programming language, Rust-based, called Sway. And overall, I would put Fuel to the same bunch as Aptos and Sui, and probably Solana as well, like tech-wise. But liquidity-wise, it's still on ETH. Like, it's an L2, so to trade there, you just lock your assets on L1, and you can easily like start trading on L2. So it's pretty straightforward. And again, from the trader perspective, it looks super lucrative. For them, it's as good as like Optimism or Arbitrum. Now, once you know all the previous things, you can build a pilot. Try building on the chain that you have chosen. Try building something like anything you already like understand. For instance, in our case, we have built a price oracle, we have built a limit order contract, we have built several things, and then we figured, okay, so this thing actually works. We can continue building on that. Now, once you have actually, hackathons are perfect opportunities, like the best opportunities in the Ethereum ecosystem to try building on any chain, because they actually pay you for like building a pilot. And we have built this thing in Denver, by the way. This was our pilot. We have built an MVP of the Orderbook DEX in just 10 days. That was, of course, a no sleep, no eat, no nothing experience. Don't try like repeating that. But and also Denver was pretty tough, like climate-wise, and it was in the mountains. Anyways, we have a great team, and they have accomplished this thing in 10 days, and yeah, we won that hackathon. But it doesn't really matter. So the pilot was there. Once we built it, we have done several benchmark tests, and we realized, okay, so this thing has some advantages with the competitors. Now let's go race to scale it. But that's just our path. I would do the first thing you do after you have built a successful pilot, if it works, because if it all doesn't work, you can scrap it and go build something else. But if you succeeded with the previous things, try getting a grant. Like go to the chain providers, go to the core team and tell, hey, I've built something, like your thing, yeah, like this shit actually works. This is something that you've been building for 3 years. It works, and normally they'd be like, oh shit, it actually works. People are building on it. Now let's support these teams. Let's talk to them. Let's introduce them to our VCs. And that's what normally should happen, but in the 70% it doesn't happen. Anyways, try talking to them and getting a grant, or talk to their VCs. They need to support this product to, pump their tokens. Now, try getting as much of L2 team support as possible. That can include intros, marketing, technical support, especially in the early days. Technical support, you will need a lot of that, because this thing barely works. Don't forget. I'm sure that if you build something that works, I mean, once you will start having some attention to your product, you're probably going to kill the testnet. Like testnet node, which I think they will only have 1 or 2 or 3 by that time, they will be dead. Like you will push the network to the limit, and you will keep the L2 team busy, and they will be super happy about that. So you need to ask them, hey, can you just do like our retweets, Can you do a Twitter space for us? By the way, you need to do all those things. You need to do some hype. You need to do Twitter spaces, and you need to do the retweets. Ask them for the interest. If you need liquidity in your product, then you will need liquidity providers. Then they probably have already like a short list of the liquidity providers and market makers willing to come and trade. And if it's a DeFi, if it's NFT, they have a list of the artists willing to do something. Depending on the products you have, like if it's a marketplace, again, they already have some short list of the artists they want to onboard. They ping them themselves. So try to get that list and build a community. Now, again, without this last thing, nothing is going to work. Like this is, again, at least 70% important. It's more important than your tech. Tech is important. If tech doesn't work, you're going to go to jail. But with this thing, it's not going to scale, okay? So once you have built that pilot, register a Twitter account, buy a domain name, start reaching out to as many people as possible. Like talking to everyone you know and tell them about this product is already a good start. Thank you. Questions?
We are on a bit of a tight schedule today, so we got time for one question. Please stay with me. Anybody? There you go.
It's a good question. and this is exactly like what we have been discussing as well. So if you need a feature from an L2 team, tell them, I need this feature, go build it. If you need a sequencing, for example, it's something you can easily build within like 2-3 months. It shouldn't be there from the box, but if they will see traction and if they will see demand like you have, you need MEV protection. Give us an MEV protection. Or you can build it yourself.
Thank you, Vitali, for the presentation. Saw that you had a very extensive list of layer 2s in your presentation. I was missing Cartesi though. But you're in luck because my colleague is here. Carlo, he's going to tell you guys all about it. Alex, can we get the other one up here? Aye. Yep. Yes. Just use the arrow keys, no?
Yeah, no worries. It works. Hello everyone, my name is Carlo. I'm one of the contributors at Cartesi. So today we're going to talk about billions of reasons to use Cartesi, and I'm going to explain why this title later on. So this is a quick overview of what we're covering today. Basically a quick overview, an intro on how to use our tech, which is called Cartesi Rollups, with interfaces, a simple example, and then a bit of what's being built with it. So this is just a preview of the feeling of how it is to develop with Cartesi. Generally in Web3, you're used to develop on Solidity and compile to the EVM. In our case, we actually enable you to have a decentralized logic, building your smart contracts with the tooling you're used to. So for the ones that are familiar with Python, this code on the right, it's a really simple smart contract you can write in Python for Cartesi. It's a basic application, and if you take a look at the code, it looks like regular Web2 code. There's nothing there screaming Web3, you're just handling HTTP requests in a way you're used to when you're on Web2, and you're using traditional Python with libraries, with everything you're used to. But I'll come to this later. Okay, so let's start with a brief overview. So what's the idea behind Cartesi? What motivated its development? So the first thing is Ethereum is awesome. It has all these nice properties that we all love in blockchains. So you don't have a centralized entity that can tell you what's going on, decide what's happening. You have all this decentralization and multiple parties that work on a consensus protocol together to settle what's reality. That gives you censorship resistance and much more things that we love. But it has its downsides as well, right? So since everything on Ethereum is secured by having these thousands of nodes replicating every single thing that's happening in the network and reach consensus already, it's basically slow. You have to wait for consensus. Resources are really limited. It's expensive because everyone is trying to use the same limited resources, so you have to bid for them. And it's cumbersome. The EVM is really cool, but it's not compatible with any other compute platform that came before. So all the tooling, all the libraries, everything is being rebuilt from scratch. So the basic idea behind Cartesi is what if we could have these complex computations enabled with blockchain security, but great tooling? And that's the basic idea we want to solve. How do we do it? We have this solution called Cartesi Rollups, in which we have this off-chain machine. That's our execution environment. It's based on an open hardware platform called RISC-V, which is really similar to ARMs we have on MacBook M1s or cell phones. And by choosing to use this, well, we can put Linux in it, because Linux is compatible with RISC-V. And by having this execution environment with Linux, well, we bring all the goodies with it. So you can use all the traditional languages you're used to, the libraries, all the environment you're used to on Web2, basically. And This is not a straightforward RISC-V machine, because otherwise it's not deterministic, and we need it to be deterministic in order to reach consensus, validate computations of other parties, and this kind of stuff. But it's really powerful tech. Unlike Ethereum, we don't have this really large amount of validators validating each application. So we have a different set of validators. It can be a small set to validate each application. And the security guarantee that our framework provides is that a single validator doing the right thing is enough to enforce the correct result. And that's because we use a dispute protocol that settles disputes using the underlying chain for security. So you can deploy on top of Ethereum, on top of Polygon, on top of another rollup solution like Optimism, Arbitrum, Madis, you name it. Just any underlying EVM blockchain compatible you want. I'm going to be brief about it, but the dispute protocol we use to secure, it's based on something called verification game. And if you guys have a doubt about it, want to talk to the deeper level, I'm available later on. So, about the tooling once again, so just being a bit more graphical. Since Ethereum is being rebuilt from scratch, all the tooling is really immature and lacking in multiple things. And when you come to Cartesi, since we just reuse everything that's on Linux, well, you have all the tooling that you're used to. On the computational side, still on tooling. So this is just a really tiny Docker file, and that's the way you settle your environment on your Cortez machine. So you start from a RISC-V enabled QEMU-backed container, and you can start from any distro you like that has a RISC-V build. So in this case, we're just using a Slim Ubuntu image, which is Slim Jenny. And then you can use all the goodies you're used to. So in this case, well, we want to use SQLite free. So here we're just apt installing it. And that's fine. And after you run this nice Dockerfile, this environment you just set is ready for your application to use. Just focusing a bit on the fact that we have these application-specific rollups instead of having all thousands of nodes validating everything. We gain a lot of scalability on computation doing this. So just some quick math here. If you take a look at the history of block sizes in Ethereum, you'll notice that the limit of all these blocks is around 30 million gas. And if you take a look at Ethereum's OP codes, you see that the cheapest useful one is adding, which consumes 3 gas. So quick math, you have around 10 million instructions as a hard limit on what you can compute on a Ethereum block, which is really little, and it gets really smaller if you use more expensive instructions like storage and other things, right? So now this is just a quick example with the Cortez machine. So in this case here, we're just booting Linux, and that's it. We're not doing anything. Just we boot Linux, and then we shut down the machine. And that alone takes about 37 million cycles of RISC-V CPU instructions. Okay, so that alone just won't fit into an Ethereum block by itself. And in case of the Cortez machine running on a laptop, that takes 0.2 seconds, so it's pretty fast. Now, if we compare to what you can do in about the time you produce a block, which is around 13 seconds, we did a really quick scripting here. And in about 30 seconds on a laptop, we did 3.6 billion instructions of RISC-V. So just to have a perspective of how that compares to the computational power you have available on a single block, considering you monopolize it, because that's not the case in Ethereum, graphically, that's what it represents. So this tiny yellow square in here would be those 30 million instructions, and then the whole grid would be those 3.6 billion instructions we executed on a Cortez machine in about 13 seconds on a laptop. Okay? Okay, let's get down to the rollups a bit. So the overview of the API, it's a bit more similar to what you would have on a Web2 application. So the client is a bit different because you have to handle 3 different interfaces. So you can use whatever tech you want on the front end. So generally, you're going to use something that uses HTML, CSS, and JavaScript, a framework like React, Angular, Vue, you name it. And then to connect on your backend, to talk to the framework, you have 3 different interfaces. One that's a JSON RPC, and that's used for providing inputs to your computation, because for data availability reasons, all inputs that come into a Cortez computation go through a smart contract of a framework on the underlying chain. So you need a JSON RPC interface to input data. Then we have a HTTP REST interface that's used for ephemeral calls, like an F call in which you don't change the state. It's just a read-only call, and that's a HTTP REST interface. And then the Cortez node also has a GraphQL interface in which you can nicely query events and things generated on your computation. From the application side on the Cortez machine, we have a nice HTTP dispatcher, which is a service that wraps the complexity of the framework and just provides a nice HTTP interface for you to interact. So coming back to that code, let's take a deep look at it. So the basic instruction, the basic set of Cartesi program is a simple iterator, and you call this endpoint called finish. And when you're calling it, you do 2 things. The first thing you do is you put a payload in there, which will either have a status of accept and reject, and that's just you telling the framework, oh, the last thing I processed was fine, you can store it, or no, it was bullshit, there's some problem with it, invalid data, so we're doing something nasty, so I reject, and I want to come back to the state I was before executing it. And at this point, the Cortez machine stops, and when there's a next input to be processed, this comes back, and you get a response. On this response, you have multiple metadata with useful stuff. You have the address of the person that sent that input. And you also have a special metadata that will tell you if that's an input that came from the blockchain, so it's meant to advance your application state, or if that's ephemeral call, like an if call, just to check some random data that later on you throw away and won't change your application state. And this metadata can be either advanced state or inspect state. And in this case, this really simple application, what's doing, it's an echo. So you throw something at it, it just throws that thing back to you. And depending on if it's this ephemeral call or this advanced state, we either call this handler or this handler. And then we're just calling 2 different interfaces. In this case, it's notice, and in this case, report, just for generating output. So this really simple program, which is using standard Python, you're using request as an HTTP client, you're using this environment module from OS to read environment variable on the Linux machine to know where this service that wraps the interface is. This is a really simple example. You're just using regular Web 2 stuff, but this is a decentralized application. And this is the server side. On the client side, on this side, we have a really simple application that's available on a GitHub repo called Rollups Examples. It's front-end command line interface. It was built in TypeScript, but it implements all those 3 interfaces. So if you do this command in there, yarn start input send -- payload, whatever you put in here, it's that call to the smart contract providing inputs for the computation. So in this case, we're throwing hello there, this hello there will come back here on this response. It's going to be processed by this handle advance. And here you're going to do this post to notice with the same payload. So now you got a notice with this hello there. And if you use the same program, but using this command notice list, then you get a nice array which has this notice you just produced with the payload you provided. So that's a crash course on Cartesi. It's this simple. Okay. Cool. Now let's take a look at some things people are building. So main uses of Cartesi in general is further decentralizing dApps. If you take a look at what's going on the Web3 space, we lack a lot of processing power and expressiveness. That's why most applications, the complex ones, they aren't actually Web3. They have a part of it, generally NFT management or something that on-chain, and most of the logic is actually centralized on the server. Like take a game like X Infinity, for instance. It's a really cool game, but it's a centralized one. The only part that's on chain is owning some certificate of something. That's something that's a monster, is actually represented on a server behind closed doors. You can nerf it, you can do whatever you want. You can tamper with the logic, no one will know. It's on a server, it's centralized. So that's the kind of thing you could decentralize further with Cortez. You can express more complex logic because, well, you have all the expressiveness of libraries and languages that have been around for decades. You can leverage traditional software stacks, so that's good for onboarding Web3 to Web3, traditional Web2 developers. Most people here that learn Solidity, I think can agree with me that's a pretty steep curve. So let's go. So first beautiful use case of Cortez is this game. It's called Dazzle. It's developed by these guys in Taiwan. And it's a really nice looking game. The client is building Unity, really nice effects. So it's basically a mashup of Pokemon and Candy Crush. So you got your team with 3 characters, the other player has another team. And when you try to attack the other guy, the move is powered by a combo you do on this shared Candy Crush-like puzzle. So just like Axie Infinity, if you try to do this with Solidity, just Ethereum traditional tooling, you probably need to put all this game logic behind a server on closed curtains. And with our tech, you can actually build it in a decentralized, transparent fashion. So this game is built in Rust, and all the game logic runs inside the Cortez machine. So every single game, you can just check that no one tampered with it. You can reproduce the computation. If someone tried to tamper with it, mess up with a random number, whatever, you can just prove and enforce the correct result. So that's really, really cool. This one is a really interesting use case. So not sure how many of you know of a lending protocol on Solana called Mango, but it had a pretty serious hack. And the problem was that Mango has a simple logic and can only use an oracle for prices to check if they can or cannot loan some money. And the thing is, this guy, he found out an asset that Mango accepted that had terrible liquidity. So he just got something like, I don't know, $3 or $5 million, purchase it. If you purchase a lot of a low liquidity asset, the price skyrockets. Then he goes to Mango and says something like, hey, give me 100 million stable coins. Okay, what's the collateral? Oh, these assets right here. He just pumped the price like crazy. So Mango goes into the price oracle. The price checks out. It doesn't have the intelligence to know that if it tries to liquidate, the price won't hold, and it's not worth 100 million. It's worth actually around 5 million. So these guys in San Francisco, they built this really cool risk analysis engine on top of Cortez. They feed prices and volumes of assets to the Cortez machine, and then inside they have NumPy, so they can do some pretty sophisticated analysis and come up with much better risk metrics. So now they can say something like, hey, you shouldn't lend more than $20K in this asset, because if you try to liquidate it, it won't hold. It doesn't have the necessary liquidity. This one is more for people into AI or machine learning and image processing. So this guy was working on a biometrics problem. Not sure how many of you know, but you have a lot of things that use biometrics to clock in, clock out, or access, or anything like that. And sometimes people tamper with the systems using a silicon finger, a photocopy of a finger, or something like that. So this program is meant to handle these situations. So in some places, people just put someone watching people clock in and clock out to make sure it's a real fingerprint. They're not clocking in for someone else with a silicon fingerprint or something like that. But there's a problem. And in general, in these situations, the party that's watching people clock in and clock out start asking for bribes. So you paid the bribe, you're there. You didn't pay the bribe, yeah, you put a silicon finger in there, you're not there, even if you're there. So it's a typical situation in which Web3 can help, because all parties are trying to cheat, and you want the system to actually work. So what this guy does is he has this Cartesi machine program, in which a first part is done in C and OpenCV. So he uses OpenCV to parse these fingerprint images and describe into an array of features. And then he feeds this into a second program in Python, in which he has this model trained to classify if a fingerprint was spoofed or not. Okay. Next one, this is a bit different. So this is a chess game from a guy from the community, but it's not a regular one. So chess has this plague that if you try to play on chess.com or other system, there's a very high probability that the other guy is just reproducing your moves on a computer program and is using the computer moves against you. So everybody's cheating, just reproducing some computer move. So this guy said, okay, so let's change the game. We want computers to play it, cool. So now he made this chess game in which you can play as a human, but it's actually featuring you training a bot to play for you. So you basically have this bot, you train it, you change its parameters, you do whatever you want to win the championship. And these championships happen inside a Cortez machine. So if someone tries to tamper with a game, say that they won or anything like that, you can always reproduce a computation and you can challenge it in case someone is making a false claim about who's got it. This one is a bit different use case. These guys are from India. So in there they have a pretty deep problem with car insurance. So when they actually need to use the insurance and they file a claim, sometimes they're denied and there's no transparency in this process. They just claim, yeah, you're a bad driver, I'm not gonna pay. And if you want to dispute it, you have to go to the justice. So that's pretty bad. So what these guys are doing is a decentralized protocol for this situation. Instead of just claiming something and having a response like, yeah, you're a bad driver, I'm not gonna pay, they have the OBD2 data from your car on chain. So most cars today have this port in which you can extract data from acceleration, brake, and all sorts of stuff from the computer. And inside the Cortez machine, they have a model that processes this data and come up with a metric. You're a good driver or you're a bad driver because you rush too much, you brake too drastically, all this sort of stuff. So if your insurance is expensive or not, if you're denied or not, it's not because of some closed door analysis, it's because the data is in there, the model is in there. If you don't agree with it, you can reproduce the computation, come up with the same metric. If someone tamper with the metric, you can prove and you can force the correct result. So it's a really cool, cool thing. And I think, okay. This is another one with games and AI. So this one is a bit different. So what these guys did is they got this retro emulator for fighting games like Street Fighter, this kind of thing. They use this Go emulator called Ikemen. They made a Python program that wraps it. And they make a fight between random characters. It's pretty fun, actually. So you have Pichu, you have Kung Fu guy, you got the pizza delivery guy, all sorts of stuff. And before a fight happens, you have a wager system. You can say, I think Pichu is going to win and put my money in him, stuff like this. Then you have the whole fight simulation happening inside the Cortez machine, and you render some cool old school style render of the fight to watch, and then it pays out the guys that bet on the winner. So that's pretty different. This one is from guys programming on a hackathon in Bogota. So NFTs have the problem that the NFT is not the content itself, it's just a certificate of what you own, right? Generally pointing to somewhere else. And you can tamper with an NFT. You can make an art and then you can just throw someone and replace the art for a blank canvas or whatever you want. So these guys wanted to tackle this problem. And what they did is there's this algorithm called Mandelbrot that produces fractal images that are pretty beautiful. So this one is an example of those. And these guys, they implemented this algorithm for Mandelbrot fractals in Rust, and they're running inside the Cortez machine. So they generate a procedural art inside the Cortez machine and an NFT collection that you can actually prove that the art that you have is the correct one. So if there's no centralized part in which, yeah, this NFT is about this image on Amazon and I swap it or anything like that, that NFT is provable, and if someone tries to tamper with it or anything, you can just show the Cortez computation and show that that's the actual art of it. A more traditional application, this is a parking app. So this is just to add transparency on something that's universal, which is you park your car, you pay for it, and then you might receive a fine or something because the officer thinks you're out of time or anything like that. Disputing this it's a nightmare, especially if you're a tourist or something you're not used to the country laws. So this is an application that was built pretty fast by some guys in Poland. The front end is in Vue, the back end is in Rust, uses a SQLite database to store information. And well, you have full transparency of what's going on. You park at this time, you covered this time, and if someone tries to issue a fine or something, it's not because they don't like you, they're doing a poor job or anything like that. It's everything's transparent, you can dispute anything. And yeah, these and others are on this showcase page that we created. There's a QR code in there if you guys want to check it out. So there are multiple ideas. There are these ones I presented and other games, carbon credit stuff, other machine learning things. So there's a great variety in there. And yeah, so as most of you know, I think, we have this if Lisbon Hackathon that's happening on the weekend. So we have a track in there. For the ones that are hacking, we got it divided into a first prize winner, which is pretty large, I guess. It's 7K USD. And then we have a share pool of $1,000 to 3 teams. So if you guys plan on hacking, you want to discuss your idea or anything like that, we'll be around. You're encouraged to talk to us. And yeah, one more thing. I'm just good, yeah. Okay, that's just one last thing. So we got this guy on Twitter saying, well, if Ethereum is really the world computer, can someone explain how no one has managed to get Doom working in it? And then we got this guy, Eduardo, in our emulator team, which is really into retro games, especially Doom. And he said, challenge accepted. So he did put the Cartesi machine to run Docker in real time. And I think that's something amazing. So we have Doom inside Cortez machine in real time, and yeah, you can just play it if you want. If you check on his tweet, missing the link, but I can give you guys later, you can watch the video recording, and it's pretty nice. So this way you can just have a championship of Doom, you play, you log into the blockchain all your moves, and anyone can just reproduce and dispute if your high score is incorrect. So that's pretty cool in my opinion. And that's it, guys. So if you guys got any questions, doubt, or anything, fire up.
You can keep that one. Thank you, Carlo. We're going to have a short 15-minute break. So if you have any questions for Carlo, please find him or his colleagues in the blue and yellow shirts. After the break, we got 3 more talks from Polygon Miden, Optimism, and Finiam, and then we'll have another short break for you guys. So please enjoy some of the snacks, and we'll see you right back. but we're gonna get started again. Sorry, I had a million things on my head. You said to introduce you?
Just say Dominik
From Polygon.
Polygon future looking zero knowledge rollup.
Future looking,
Zero
zero
knowledge
knowledge rollup.
Exactly.
I should be able to remember
future
that.
looking ZK rollup.
All right, I see that the last people are moving back. You guys want to take a seat too? All right, let's get started again. Our next speaker is Dominik from Polygon, the future ZK rollup. Dominik, I'm going to hand you the mic and the remote. Take it away.
Thanks. Thank you very much. 1 second. Oh. It's yours, I guess. Hi, I'm Dominik from Polygon Miden, and we try to build with Miden a new design space to allow for different applications that are currently not possible on Ethereum. Like this? Ah, perfect. One second. It doesn't work. Closer to what? Oh. Can also, I just do it with the computer, like this. So, I want to say that, as you probably all know, Ethereum is still our best bet, right? When we compare different blockchains on the amount staked for security and the active developers, then we see that Polygon, Cosmos, Polkadot, they're all quite close. Solana might be a bit of an outlier in this group, but Ethereum is by far the best bet in amounts of active developers and token staked for security. So when you want to build a new dApp, it would be stupid not to tap into the Ethereum ecosystem. However, Ethereum and the EVM is also quite limited in terms of what you can build there. We can build many very cool applications, but we will always end up, at least for now, that the EVM processes the state changes sequentially, right? So one account after another are being changed. And like this is my PayPal account. If PayPal would have been built on Ethereum, you would all see always my PayPal account. And the EVM basically is very hard on privacy, and most people would not use PayPal if it would have been built on Ethereum. So the EVM has limitations. It is not suitable for applications that require very high throughput. It is that complex computations are very costly, as we've seen with Cartesi now, and transactions and accounts are publicly available, so everyone can basically see everything if they can link this public key to your name. But like real-world use cases, like exchanges or games or even money transfer, they need properties of the blockchain to be very fast and very cheap. They, we think, also need parallel execution or concurrency, we need to have at least partial privacy, as we can see it in Web 2 applications. We need different way of wallet security as it is with this public and private key pair. And we need way better user experience if we really want to onboard the next 100 million people. And so the question is, how can we use Ethereum but not the EVM? And basically, the answer, as you all know, is rollups. Rollups can be cool design spaces. And what rollups actually do is they track a state root of a global state on Ethereum, and they prove to Ethereum, optimistically or using zero knowledge, that the state change of the global state in the system behind it was correct. But obviously, these rollups are not bound to use the EVM or are not bound to mimic exactly the behavior of Ethereum. It's cool when they do, and this is a true scalability solution then, but a rollup can also extend the feature set of Ethereum. And what I want to say basically is behind that global state root, there can be anything, like any network topology or a different network. There can be different state models and execution models. And we might even see Bitcoin as a rollup on Ethereum, even though that might be a bit difficult because it's a proof of work network. But like, you get the point, I guess. So we can basically, behind this global state root, that we prove to Ethereum that the transition is correct, we can have it behind basically anything. So rollups are already design spaces. Some basically leverage privacy, and Aztec, for example, will be the new version of Aztec will be a rollup secured by Ethereum, but adds way more privacy as in the rollup. We see rollups that basically use the UTXO model for way higher throughput, like Fuel or any others. We have, for example, Starknet, and Starknet doesn't optimize for privacy or throughput, but maybe for usability, but it adds new features using a different VM to Ethereum. And we have basically Polygon Miden, where we now try to add privacy and throughput using a new state and execution model. So how we do it, basically Polygon Miden is a zero-knowledge rollup that tries to extend Ethereum's feature set. So we still inherit its security, because it would be stupid not to tap into the Ethereum ecosystem, but we try to not limit ourselves by the EVM. And that's the cool thing about rollups, right? So you can basically use a rollup as a design space and build anything and just try it out. So Polygon Miden is a general purpose zero-knowledge rollup on Ethereum. And our goal is that you can create applications that are impossible or difficult on the EVM. And as Polygon Miden works with the Miden virtual machine, a zero-knowledge prover basically, that prioritizes ZK friendliness and performance over the EVM compatibility. And so we do not work with Solidity so far, but I'll show you later how it works. And what is actually new, I would say our core feature is client-side proving. So basically any user on Polygon Miden will be able to create its own zero-knowledge proof of its own state transition and prove it to the network, and the network only verifies. And this gives us very cheap and private computations. So basically the users on Polygon Miden will not be limited by the block size or that the network recomputes every single step, but they can just compute on their local machine something, create a proof, and send it to the network. And for that you need a very performant virtual machine, obviously, a performant prover. On Polygon Miden we will have off and on-chain data, so you can store your data with the Miden operator and have it fully on-chain, but you can also just have a commitment of your state on the rollup, and then no one knows what's actually behind your account. And there could be, again, anything. So in theory, every user on Polygon Miden would be its own layer 3, always proving the correct state transition of your account to Polygon Miden. This as a feature gives you the ability to hide account and transaction data. When you think of, I don't know, institutional investors on a decentralized exchange, for example, then no one will see your strategy or how many assets you have. In Polygon Miden, we try to have parallel transaction execution because we don't follow the Ethereum account model, but we have a hybrid between an account model and a UTXO model. We can parallelize transactions and parallelize proof creation. And if every user can just create proofs on their own computer, they only need to be verified, which is way faster than executing and proving by a single centralized prover. And this basically helps developers to build high throughput applications. And for example, an on-chain order book exchange. And another feature on Polygon Miden is that you can update and recall transactions, meaning that you can place an order at a decentralized exchange and say, I want to trade 10 ETH for 1000 Matic, and if no one takes it, you can basically for free and in no time update your transaction and just say, okay, now I pay 10 ETH for 900 Matic. And another cool feature is that you can recall transactions, meaning that when you send something to the wrong address or no one wants to take your order, then you can just say, okay, I just take it back. And so there is no, like, it's never lost. And this, we think, helps developers to build more user-friendly apps. Okay, a short description how it works. Basically, on Polygon Miden, there are accounts and nodes as the core concepts, and both can carry assets. Accounts is the same as on Ethereum, so a user is behind an account, and this account has several assets in his storage. And but these accounts, next to the accounts, there are also nodes, like bank nodes, and these nodes also carry assets. And basically, the accounts send nodes to each other that are consumed by another account, and then you have the assets sent. So basically, we rethink how a transaction works. This is based loosely on the actor model. I don't know if you know it, the actor model in decentralized databases, where always also like an actor is responsible for its own state, and they send messages to other actors, which is another little state machine with an inbox, and these messages can trigger a state change on this actor, and this state change can then produce other messages to send it to other actors. And our actors are accounts, and the messages are nodes, like bank nodes you can send to each other. And so a transaction basically is always being executed against a single account. Recall in Ethereum, a transaction always had at least 2 accounts at the same time. And in Miden, basically a transaction changes the state of a single account. And by doing so, it consumes nodes and it produces nodes. So in this example, this account basically, who has 3 Ether, consumes a node with 2 Matic. And at the end, it has these 2 Matic in the account, but has to pay 1 Ether for these 2 Matic. So it produces a node and consumes a node, and this is a transaction. And transactions can actually consume up to 255 nodes and produce many nodes. And so basically you can do it all in the same transaction. And that means, like this model means that if I want to send an asset to someone, I always need 2 transactions. Like one transaction to create this node, which is then somewhere in the network, and another transaction to consume this node. And why are we doing this? Because every transaction always involves only one account. This account can create a transaction proof for its own state transition. The transaction basically is only a transition function of this account. And then, like these transactions are basically distinct from each other and can be processed by the network asynchronously, right? So you can basically, every account can create its own zero knowledge proof, or you can also say the network should create my zero knowledge proof because I'm on a mobile phone. But the fact is that they are distinct from each other, and so we can parallelize it. And this is how we get parallel transaction execution. So we rethink how transactions work with this model, basically. So basically, for every, there is a proof for every transaction. This is the basic building block of Miden. And these proofs are then being verified. And proof verification in zero knowledge proofs is way easier than proof creation. So proof verification only grows logarithmically, and that means the network can process many more, can verify many more transactions than it would need to produce proofs or execute the transactions itself. So basically, there is a Miden operator, or in the future there will be a decentralized set of Miden operators, and the users can decide if they want to have network proving, and then Miden would work the same way as other zero knowledge rollups. Basically, the user prepares the transaction, signs it, and sends it to the network. And in the network, there's a sequencer and a prover, and they basically wait until they basically process all of them, all of the user transactions later on. Or the user can decide to prepare, execute, and prove the transaction himself, and only sends the proof to the Miden operator. And this guy here on the bottom would be able to transact privately on Miden, because the Miden operator and the other network participants would not actually know what happened. They would only know that something correct happened, right? And so they would know, okay, this guy did a correct move in a game or a correct trade, but we don't know what actually happened. Because basically, this guy in the bottom is its own rollup. It just proves to Miden and not to Ethereum. And the Miden operator would then, in recursive verification, batch these proofs together in several steps, and at the end, prove it to Ethereum that everything is correct. So Miden, again, like inherits Ethereum security by proving at the end that everything that happened in Miden was correct. But sometimes the network doesn't know what happened. And what you can build then, basically this was or is the goal of my talk, these novel applications. In Miden you would be able to build on-chain order books, which is quite cool. Like 90% of all tradings in crypto or in the real world, maybe even more, happens on centralized order books. And on Ethereum or the EVM is not performant enough. That's why we invented all this, like AMMs and some other DeFi applications. But Miden is actually performant enough to have this on-chain order book, because you can update your transactions, and it could provide privacy for any investor. So it could be a very attractive way not to use Binance or Kraken at the end, but you could have everything secured by Ethereum on chain in a very high performant way. And you could also have cool multiplayer games, for example, that have these hidden information or incomplete information games. And you could have the whole game logic behind a global state root or behind an account again. And so the game company could prove always to Miden itself that everything was correct. And it could be fairly complex because they don't pay gas for it. They only pay gas for the proof verification at the end. So the whole gaming could be different on Miden. We can build way more complex games. And Another cool feature or application we think of is smart wallets or sovereign wallets. In Miden, every account is a smart contract, so we have account abstraction, but many other projects have also account abstraction. But we can also partially or fully hide the state. So when you are a founder of a crypto project, for example, you can put your money in a wallet on Miden, and your competitors would not see, or the hackers would not see, how much asset you have. And so the attack surface for hackers, for example, is way less. And I think my mom would also use a wallet where not everyone can see how much she has or what she has bought, like in this PayPal example. And in Miden, it's possible to still stay on-chain and have a private, partially private wallet. And you can show basically the wallet contents to anyone you would like. Just shortly about our roadmap. Basically, in July, we want to be able that Alice can send something to Bob. So our very first testnet. And in October, we want that developers have a fairly good experience in our public testnet. And we want to have the first projects to build on Miden, cool novel applications. And we approach mainnet in Q1 next year. And what we already have, I want to show you, maybe you can take your mobile phones and scan this QR code, is the Miden VM. The Miden virtual machine was being built now for over 3 years. It's a Stark-based virtual machine, same like, bit like Starknet. And this is our playground. You can see that it is optimized for zero knowledge, meaning that our programming language at the moment is Miden assembly. You can see when you scroll down a little program that adds, like it's in assembly, but it adds 1 and 2 together. And when you click on proof in this button above, maybe you can click on it. On your mobile phone, was it in under 1 second or above 1 second, under 1 second? Ah, sorry. Maybe I go there. And this is how you can see, basically users will use a wallet or a Miden client that incorporates the Miden VM, that runs on the Miden VM. And we try to make it as performant as possible, such that you can basically also create proofs on your mobile phone, but at least on a MacBook, and so it's quite fast. And you can also play around with it when you say you can prove something, then you can see the proof. But you can also now, when you have proven something, verify it, and you should see that it should be only in 1/10 of the time to verify. And when you now want to play around and change something in the program or in the inputs or in the outputs, then it should not verify anymore. But yeah, this is our core feature, basically, I would say, client-side proving next to others, and therefore we built this performant VM. And next year there's mainnet. Are there any questions? Yes, that's a very good question. Yeah, Polygon has like 3 different zero-knowledge products. And at the moment we are designing how it works, but most likely we will use the same bridge and liquidity pool. And the vision is that if you need to go to very high performant or private apps, then you should be able to bridge in no time to Miden, use an app, maybe move back, and so we will use the same bridge and maybe for the last step the same prover, but this is not specified yet. But basically Miden is complementary to the ZK EVM. So there are apps that are very suitable for EVM-like systems, and there are other apps on Miden, but we somehow want to tap into the same liquidity. Yeah. It's a vision so far, and I have not seen the specs so far. So yeah. The nodes coexist to the accounts. Basically, there's an account database which tracks the state of all accounts, and there's a node database which tracks the state of all nodes, and there's a nullifier database which tracks which nodes have been already consumed. Yes, it depends. You can store nodes publicly, and then everyone can see how the nodes looks like. Nodes consist of a vault, and that means which assets it carries, and a node script. And when you want to consume the node, then you have to execute the script. And this can be publicly available for everyone to see, and then basically, I don't know, everyone could consume your node. Or it can also be only stored the node hash, and then only persons who know the node data could consume that node, and you need to send them the node data in a separate channel. But yeah, these would be the two ways to enable private transactions, but also public transactions. And you could also, another important thing is that on this node database, it's an append-only data structure or accumulator. It's a Merkle mountain range, and that means that you can parallelize node creation as well, or always put new nodes on it. And the nullifier database only checks is it consumed or not, but you cannot link those. If you don't know the node data, you would not know what the nullifier of this node is. And then I hope this answers your question. Cool. Thanks a lot.
Thank you, Dominik. All right, then we're going to go from Dominik Schmid to Kirill Schmid. He is with Hexen, a cybersecurity company that does smart contract audits. Kirill, please join me on stage. I think only one mic is working, so I'm going to give you.
Thank you. Hi, everybody. First of all, I'd like to thank the organizer of this event, Oli, Alex, for your constant efforts to gathering the Web3 community all together here in Lisbon. Obrigadíssimo. Yeah, my name is Kirill Schmid. That's funny. I'm second speaker in the row with the same family. And I am CBDO of the Hexens, a cybersecurity company with the focus on novel cryptography and smart contract audits. Probably you have mentioned that we are a security partner for this event. And of course, I would like to tell you a bit more about the Hexens. So that's why I'm prepared quite short presentation. It's roughly something about 40 pages only. And the next couple of hours, I will. I'm joking, of course. So I think we do not have enough food for such timing. Just only thing that I would like to highlight. As a cybersecurity company, we strive to elevate the security level of for the whole Web3 space, for all participants and stakeholders, for founders, for investors, for users, for developers. And if it sounds meaningful for you, if you're sharing our mission, and if you work hardly to protect your project from any cyber threats, we definitely have to talk. So please contact me anytime this event or later. And that's all from my side. Stay safe and have fun. Thank you for your attention.
Thank you, Kirill. All right, then for our next speaker, please give a round of applause for Kelvin. Kelvin is with the Optimism Collective, building an army of developers. Please elaborate.
Hello. Hi, yeah, my name is Kelvin. Damn, I had a lot of caffeine, so we're really gonna be going here. I also did not time this talk, so I have no clue how long it's gonna take. Oh no. Well, that's wrong. The R should be over there, so I don't know. Whatever. Yeah, so I'm gonna give this talk called "Rollups Aren't Real." This is very important. You should know this. Rollups don't exist. That is to say that there's no such thing as a rollup blockchain. This is fake news. You've been bamboozled. This doesn't exist. You should be aware of this because it's very important. Okay, some context. I've given this talk before, kind of, and I'm trying to make it better, so I'm just going to keep giving it until it sticks. This is more technical. I don't have my drawing tablet, which I usually have to do the silly drawings, so unfortunately I could not do the silly drawings, so it's all bullet points. But whatever, it is what it is. All right, so I've been told that if your talk is better if you give a table of contents. So this is the idea. So the mental models are broken. We're going to talk about state machines, and then data availability and ordering, observers and bridges, and I'll propose a definition for what a rollup really is. All right, let's get to this stuff. Okay, so this is what everyone thinks a rollup is, right? There's like a sequencer, and it posts transactions to an L1, and then there's like some kind of proof mechanism that protects the rollup. How many people here were like, yeah, that's a rollup? All of you, every single one of you, I know, but you're wrong. Everyone's wrong, because everyone's wrong. All right. And the reality is that this is a mental model that's developed over like the last kind of 4 years. This stuff started, like terms like sequencer came around before the idea of blockchain modularization was really a thing. Like this all just, it just came together. Like our understanding of what a rollup is today is not a rigorous thing. It's just words that have developed over the last 4 years that we threw together in a way that like kind of makes sense. But if you actually think about it for 2 seconds, it doesn't make any sense at all. So, To make this point, I want to go back to some very basic elementary computer science and show you some, make a couple statements here, right? So blockchains are state machines. If you're here, you're a developer, you probably know that. 2 key components, right? You have a state and a state transition function. The state is like the memory of a system. Have you ever tried defining state succinctly? It's like impossible. I don't know. It's the memory, I guess. You probably get this intuitively, but try to tell your mom about it and you'll have no clue. State transition functions, right? You have some mathematical program mathematical function that you can represent as a program. It takes the current state, it takes some external input, and it generates the next state, right? So you're transforming the current state into the next state. Probably seen that a million times too. Pretty simple stuff. Okay, quick aside. I'm going to throw some asides in here just because it's fun. There's no such thing as invalid inputs in state machines, right? So if you think about like the EVM, you think about this concept of an invalid transaction. The reality is like you can feed any input into the EVM and it'll throw an error. But throwing an error is really just like a nice way to say that the state transition function did nothing, right? And we don't want to include state transitions that do nothing, so we call them errors and we force people to throw them out. But I mean, if it was an invalid input, how could you even run the machine in the first place? You're running a piece of code that throws an error. So that error throwing code is part of the machine. So anyway, aside, interesting stuff. All right. Illustrating the state machine, you've probably seen something like this before, right? You have an input, you have a current state, you feed these things into a function, generates a new state, you go do this loop-de-loop thing, and you can do this forever. And you're transitioning your machine forever. All right, why am I talking about all this stuff? Okay, right, so this really, really simple diagram also describes Ethereum, right? You can make arbitrarily complex programs that actually just look like this. And I'm going to give you an example of one because it'll be relevant in a minute to the whole roll-up discussion. We're going to do this thing that I'm calling the toggler. The toggler. So the toggler is a simple state machine. Starts with an accumulator, like a sum, and it's going to add the first result, subtract the second, add the third. You'll see in a second why we're doing this, right? So you have an input. You have the current sum, you have a toggle, and it's just going to add the first time, and then the next time you run the state machine, it's going to subtract, right? So let's run it once. You have this current thing. I'm using like 1 and -1 to represent adding or subtracting, whatever. It doesn't really matter. Point is, you start with, so the first time we run this machine, we have the current state is 10, the input is 1, and because this is positive 1, we're going to add it, right? So our new state is 11. We added the first time. The next input that I'm going to pull in, we're back to 11, right? Because that was the output of the previous execution. And now we're subtracting 2, right? Because our sign flipped here. So we're subtracting 2, and the final state is 9. All right, why did I go through all that trouble? Because ordering is important, right? State machine output often depends on input ordering. It's critical, actually. So, right, watch what happens when we modify the ordering. So if we modify the ordering, we just flip the input array. The first time we add 2, we get 12, right? Then we subtract 1, we get 11. It's different than 9, right? 11 is different than 9, I think we can all agree. So ordering is really, really important in these systems, generally. Important property to understand, ordering is critical when we're talking about the input array. Now, we're going to play a little game, all right? I got this array here. All right, look at this array very carefully, this list of numbers. Has everyone had a chance to look at the numbers? Just kidding. What was the original ordering? Can anyone tell me? Can anyone? No, you can't tell me. What were the inputs at all? I bet none of you have any clue unless you rewind on the live stream. No one can tell me what the inputs are. So that there are really 2 key properties here. There's ordering, and then there's the preservation of the data itself, right? In a real, like when we talk about these weird state diagrams, it's always given to us by fiat. We have this input array, and it's just in the diagram, and we're like, okay, I guess that makes sense. In the real world, you lose data, right? Like the data needs to sit somewhere on a machine in the real world, or it needs to be written down on a piece of paper or something. But if you don't preserve that data, you're going to lose it. And if you lose the data, how are you going to execute the machine, right? So really, the critical thing that we have to do is data preservation. So this is really like, this is all the whole point of fault tolerance and replication in all these blockchains is to replicate data so that we don't lose the inputs, so that people can actually re-execute the state transition function and get the result again. If you lose the inputs and you don't have a way to deal with that fact, then how does anybody know what the state of the system is, right? So you do all this work, right? You know, at home you might replicate your data to another machine. At some sort of enterprise environments, you just need the basic crash fault tolerance. And then in adversarial public environments, you need Byzantine fault tolerance, which requires consensus, right? So we did all this work, blah, blah, blah. And then we realized why we need blockchains, because we want these state machines that anyone can publish to. And we need to preserve ordering, and we also need to preserve the availability of the inputs, because if we don't know what the inputs are, how are we supposed to execute the machine? So Byzantine fault tolerance is hard. Doing this in a public, open, decentralized, adversarial environment is even harder. It's really expensive, and no one likes to do it. But luckily, we already have existing blockchains that do this for us, and Ethereum is one of these things. So the first realization is like, well, we can reuse this property, right? We can reuse the fact that somebody else is already doing all the hard work of ordering information, right? Again, ordering is critical. And of making sure that that information is around so that we can actually grab it later on and execute on it. So these are the 2 key properties. And sort of the realization, well, okay, one sec. I threw this aside and whatever. ConsenSys is part of the state machine, so this is just something that's interesting to know. This diagram's kind of small, but, ConsenSys, like there's one big state machine that includes ConsenSys, whatever. Okay, back to sort of definitions. Like a rollup isn't real, why? Okay, what is an L1 blockchain? I would propose that an L1 blockchain independently preserves its own input array, right? So it's preserving that array of inputs that ultimately defines the outputs, and it's doing it independently. It doesn't rely on the behavior of some external system. Usually in the blockchain context, that means economic independence, because we use economic properties to sort of guarantee the availability and the ordering of these inputs. An L2 blockchain has an external dependency for input array preservation, right? It relies on a third-party system to maintain the ordering and the availability of its inputs, which ultimately defines the chain itself. And so this is an economic dependence. And because you have this economic dependence on a third-party system, you don't really need your own consensus mechanism. There's sort of an asterisk here, which is that you can put your own consensus mechanism into these things, but this is why like all the L2s just have sequencers, right? Because you don't need a consensus mechanism. You can just rely on the consensus mechanism of a third-party system. So, okay. All right, another quick aside here, whatever. You can separate, right? You can separate ordering and availability. At small scales, these are basically the same thing. At larger scales, it can become worth it to separate ordering and availability. The standard strategy is you order hashes, and then you store the pre-images somewhere else. So if you wonder why people talk about data availability separately from ordering, it's because you can do this thing where you just store the hashes. But they're basically the same thing. All right. So what is a rollup? What is a rollup? This is we're getting to the point of the whole talk. A rollup is not a type of L2. Anyone who tells you that is lying. A rollup is about how an L2 is observed. So what does that mean? It's very weird. So rollups, I argue, are about the observer. So what is an observer? An observer is an actor on some external system, a third-party system that is looking at another system. Observers understand that they can scale resources by offloading compute, right? A smart contract can scale its available resources by offloading its computation somewhere else. And we say that we can securely scale, right, 100% securely scale, if we don't add new trust assumptions. If the trust assumptions are the same, then we have securely scaled. All right? If somehow Ethereum could process 10 times as many transactions and the trust assumptions stayed the same, then we've scaled 10x. So the rollup observer is a thing that adds minimal new trust assumptions. And we'll get to the sort of wishy-washiness of this in a second. It adds minimal new trust assumptions. So what are the observer, generally, just for a sec? It's any smart contract that's reading the state of our L2 or of any other system that exists. You know, for example, let's say a smart contract on Ethereum that's reading the state of a smart contract on OP mainnet. A very common example that people are really familiar with is bridges, right? Bridges, in order to process withdrawals, have to observe the state of the L2. So the rollup observer, the way that this works is that it's a relationship between the trust assumptions that the observer needs to exist in the first place and the trust assumptions that it uses to read data. So we'll get to some examples here. And the rollup observer we define as this thing that has minimal difference in assumptions. So here's an optimistic rollup bridge example, right? Like I said, let's say you have a bridge on Ethereum. You're observing OP mainnet, right? So the L2, posts data to Ethereum. We have a smart contract bridge on Ethereum, and it uses an optimistic proof system. So what are the assumptions that underpin the bridge's existence? It's basically like the Ethereum economic assumptions, right? The assumptions that are required for Ethereum itself to function. And some cryptographic assumptions, all these things that Ethereum, that anybody, if you have a wallet, right? If you have a smart contract, for that contract to continue behaving normally, you make certain assumptions that Ethereum is going to behave normally. So those are the assumptions that underpin the bridge's existence. But what assumptions does the bridge need to make to read data from OP mainnet? So you make the same Ethereum assumptions, and now you're making these two extra assumptions, right? You're making the assumption that the challenge code is correct. It's always going to invalidate bad results, and it will never invalidate good results. And you make the assumption, this economic assumption, that someone is incentivized to actually challenge all bad results. So you've made these little assumptions here. ZK system, right? Imagine we have the same thing except it's a ZK proof system, right? So same assumptions underpin the bridge's existence. It exists on Ethereum. But now we have different assumptions about how the bridge reads data. The bridge makes the assumption that the circuit is correct, and it also makes the assumption that the underlying cryptography is sound, right? And then this Celestium bridge, right? This idea that you post data to Celestia, but you have a bridge on Ethereum, and let's say it's still an optimistic proof system. So what assumptions underpin the bridge's existence? Well, it's the same assumptions as all the other bridges because it's just a smart contract on Ethereum. But what assumptions does the bridge make to read data? So now it's making the same Ethereum assumptions. It's also making this new assumption about Celestia correctly ordering and maintaining data. And then it's also making this new assumption that there's this data bridge between Celestia and Ethereum to bring the block headers over, and that is sound. And then you're making the same optimistic proof assumptions as before. And so then there's sort of this question of like, what makes the first two a roll-up and the Celestium thing not a roll-up? Like, where is the line between, you know, we don't call this thing where you post the data to Celestia a roll-up, and it's in practice, it's just a difference in security assumptions. Is it just the fact that the data is being posted to the same place where the smart contract is? But what if the data is being posted to the same place that the smart contract is, and then there's a whole bunch of terrible security assumptions underneath that? Like, there's this weird line. And you know, the argument is that rollups aren't real. Like, there's no such thing as an L2 because this security property thing is not about the L2. It's a descriptor of the bridge. Like, none of the stuff we just talked about determined properties of the L2. We just said that the L2 was this thing that is posting data somewhere. Maybe it's posting data to Celestia. Maybe it's just we just said there was a concept of an L2 that I defined earlier. It's posting data to some third-party thing. But like, I guess we could say, if you want to think about it that way, then all L2s are rollups if they're posting data to a third party. But I would say that that's actually an L2 because we have this weird, we like to say that there are some L2s that are rollups and then there are some L2s that are not rollups. And then, so let's just ignore the word rollup and say they're all L2s. And so then the properties get weirder when we realize that different bridges can observe the L2 at the same time. Right? There can be a bridge that has strong security assumptions that observes the L2, and simultaneously there can be another bridge that has very weak security assumptions that observes the L2. And let's say one uses an optimistic proof and one uses a ZK proof. Is it a ZK rollup? Is it an optimistic rollup? It's neither. It's not. It's the L2 is not a rollup. The bridges have this thing that we call rollup security. And that this definition is just very tenuous. There's this arbitrary line that we've drawn that we just say like, yeah, this is like trust minimized enough. Like if your assumptions that you make, the difference in assumptions between the existence of the bridge and reading this other third-party smart contract are, you know, minimally different, then it's a roll-up. But again, the roll-up is not a descriptor of the bridge. So theory as to why we call L2s roll-ups. The reality is that bridges generate assets, right? Bridges can communicate to the rollup as well. Bridged assets share the security model of the bridge. And the proliferation of bridged assets ultimately impacts the chain economy. The higher percentage of a chain's economy that is essentially hosted by a third-party bridge, the more influence that bridge has on the blockchain. And since the vast majority of assets today, L2 assets today, are backed by these big bridges, they essentially dictate the economic security of the L2s. And because powerful observers always determine forks, they dictate forks as well. And the end result here is that the big bridges essentially own the L2, and the security model of the big bridges becomes the security model of the L2. Because if the bridge fails, essentially these L2s fail as well, right? If the main OP mainnet bridge failed, likely that most of OP mainnet also fails. Just in terms of not in terms of actual impact on the state, but in terms of the economic impact it has on the chain ecosystem. So this is what creates that confusion in mental model. It's this power that the bridges have over the L2 in their current states. Don't listen to the lies. Does USDC define Ethereum? If USDC failed, would Ethereum fail? No. And in that same way, if a bridge failed, if small bridge failed, would an L2 fail? The answer is no, but it depends on how big the bridge is. There's a strong incentive to keep bridge power centralized because bridges are ultimately the things that can be governed. The L2 itself cannot be governed. This is sort of something, this is for another time, but the bridges can be governed, and this creates an enormous incentive to have these very, very, very powerful bridges that hold the majority of assets, because it essentially gives something for the DAO to govern. So yeah, a rollup bridge, doth not a rollup L2 make, and at a fundamental level, rollups aren't real. I'm correct, everyone else is wrong, say it with me. Rollups aren't real. Thank you for coming to my TED Talk, we can argue more later. Yeah, there's a lot to talk about here, but the key thing is rollup is not a property of the L2. We used to think that it was, but that's because we have a very limited view where there was one bridge and one chain. But there can be many bridges and one chain. So is it a rollup? Is it not a rollup? I don't know. It's an L2. It's definitely an L2, but it's not a rollup. There you go. That's it. All right.
Thank you, Kelvin. Don't go yet. We have time for one question, then we got to move on. Is there anybody who wants to ask something? I think your story was quite full and extensive.
Yeah.
So maybe you already covered all the questions without knowing.
I don't know. We can talk later.
All right. Then I want to thank you for your presentation, and I'm going to quickly invite our next speaker on stage. It's José, the CEO of Finiam.
Hey everyone, so why I am here, as they said, I'm José, I'm the CEO of Finiam. We are a dev shop based here in Portugal in the northern part. I'm in no way affiliated with Starkware or Starknet. I'm just a random community member that is participating in this ecosystem, and I'm basically, with this presentation, I'm trying to explain to you why me personally was drawn into Starknet, why we started as a company developing things with other partners in Starknet, and why we are trying to contribute to this ecosystem. So, random agenda for the presentation. As any good speaker, it comes at 3 parts. As everybody knows, is the superior method of telling a story. So let's start with why you should care about Starknet. And I think for me, the thing that drawn me about this, it was really this first statement, the part about integrity via math. And the way that we can think about integrity is that, like a classic C.S. Lewis quote, integrity is doing the right thing when no one is watching. And I think that really encapsulates the motivation why ZK rollups or validity rollups are really important, because it's really one way of us using a novel tool, a new mathematical tool, to expand the integrities about our computations. So in the case of Starknet, it uses ZK Starks. This is pretty new technology. It was launched in a paper back in 2019 by one of the founders of Starkware who built Starknet, the Eli Ben Sanson, who, together with his co-workers. Maybe looking back at the history of the tech behind ZK Starks, we should probably mention like interactive proofs that were discovered back in '85, then the PCP thing, where like in the '90s people really come up with the like basic mental model about ZK Starks that are basically a evolution over the PCP thing that is like provably checkable proofs. And if we want like a good mental model about that, it's basically taking a computational statement and converting that into a Sudoku puzzle. The fancy part then is with polynomials and very fancy math, but at the end of the day, the way that you can think about computations when you are talking about validity proofs or zero-knowledge proofs is basically, no matter your program, the bigger the program, the bigger the Sudoku puzzle that you are solving. But at the end of the day, it's the same thing. It's like a math problem. You have constraints. Every square needs to have the number 1 to 9, every line, every row. This is just like a simple mental model, but the actual thing is then just taking this Sudoku puzzle and converting it into polynomials and algebraic intermediate representations and all fancy terms that are really cool. But at the end of the day, I think the Sudoku puzzle thing is the good mental model for people coming into the space to understand what the zero-knowledge proof is and then go and dive further. And back to the PCP thing, just because in '95 there was this really cool paper about polynomial times, about these proofs that had this awesome quote, because I think basically represents how this came up into blockchain. So basically the concept of a single reliable PC, and we need to think of a PC back in '90s, the computation power that entailed, can basically monitor the operation of supercomputers, because the way that you verify the computation is very performant, so you don't need to re-execute the code to make sure that what transpiled through the computation is what actually matches your output. So yeah, I think this is really the way that we can think of like Ethereum as the single reliable PC, because of the trust assumptions that you have there, and then you can take like off-chain computation, and through zero-knowledge proofs, validity proofs, whatever you want to call it, you can make sure that the computation that is happening off-chain is really what is supposed to happen. And this brings us to why this is very exciting and why it's being applied to scaling Ethereum. Basically, it means cheap computation. This diagram pretty much sums it up. You need a big computer to generate the proof, but then you can have a very small computer, in this case like a smart contract on Ethereum, that can verify the proof, and you can make sure that the computation occurred as it was supposed. And basically this amount of big computation, or of cheap computation, enables us a lot of more use cases that right now in blockchain they are not economical or feasible, and maybe even they'll never be on something like Ethereum because of the evolution so far of that. So something like complex gameplay on chain. Everybody's talking about ZKML nowadays, and like verify the inference models, putting the neural networks weights on chain, and then you can validate that actually what was supposed to be GPT-4 running is GPT-4 running, and not OpenAI using GPT-2 just because they want to save on costs because of the model. It's cheaper to run. Something like getting information from other chains with storage proofs. I'll talk a bit more of that ahead. And then things like autonomous worlds. Nowadays everybody is talking about that. I think ETH Global will also be doing another online hackathon soon regarding that. So I think it's really an exciting time for gaming on chain. And finally, this thing like layer 3s, app chains, whatever you want to call it, the way with zero knowledge proofs of guaranteeing that the computation occurs as it should, it's really opening a new design space about what we can build on top of the blockchains, and even on something like Starknet, enabling for you, when you are building your layer 3 or your app chain, to take different decisions that were made with Starknet and take decisions that are useful for your use case, and not just some random network that needs to have very high trust assumptions. And with zero knowledge proofs, then a lot of fun things can happen. This is like why I'm interested in this. Talking about the tech, everybody doesn't like Cairo, I would say, because if we look back at Cairo 0, that was a big problem regarding like the dev experience developing Cairo. I think nowadays, as we can see by this screenshot, it's very Rust-like with the development of Cairo 1. So it's a lot better nowadays for devs developing on Cairo. Cairo is basically a high-level language where the main feature is that it's very easy to write provable programs. And this also comes from the name Cairo itself. Cairo came from like CPU air. So air is the algebraic intermediate representation, something that you get, for example, with CIRCOM, when you are designing circuits and then you need to select your verifiers. You are basically like designing an air that can be provable. And Cairo is basically a CPU. It's a way for you don't need to worry about that, and it just guarantees that you are coding high-level languages, and under the hood there is a very efficient way to create ZK Starks that prove the computation as occurred as it should, and your prover that can be a big computer, because there's still some scaling issues, generates the proof, and you have a verifier that can then easily verify that the proof corresponds with the computation. I think that looking at Cairo 1 and explaining a bit how everything worked and why was there a need to have this big change between Cairo 0 and Cairo 1, it was basically, I would say, from a development experience, like the language itself changed a lot. It was moved into a more like Rust-like syntax, but also because of Sierra, because until Cairo 1 we had the problem of transactions could be a failure. So the computation, instead of being just true or false, it could be a failure. That means when we were trying to prove the computation, we were wasting cycles trying to prove something that would just fail at the end and would not be neither true or false. Sierra was basically built as a way to guarantee that every program that you write on Cairo will either yield a true or false proof, and that way every computation is valid, I would say. And at the end of the day, this is just another compilation step. So we are writing Cairo, the Rust language. It's compiling to this big ass JSON that is the Sierra, that afterwards is compiled into CASM, and CASM is actually what is deployed, Cairo assembly, into the Starknet blockchain. And that's like the restricted instructions that can then be proved. But at the end of the day, you don't need to worry about this, but that's why it's cool that someone is building something like Cairo, and it brings a different trade-off than using Solidity or trying to do something using EVM. You need a Cairo VM for Cairo, and it's really something that is technological, interesting for us to explore. And finally, the Starknet itself. So it's a layer 2. If you are here, you probably already know most of this about layer 2s. You have a sequencer, we have a validity proof. So you have a prover that needs to take the block and create a proof for it. That gets into the Ethereum, where you have the verifier that basically is a fact registry for every block. And then you have the actual Starknet core contract, that it's the bridge that deals with taking the data or managing the data for the entire rollup. Looking at like what you should pay attention, again, just my personal experience or things that I find interesting about this. If you are new to Starknet, or if this is something that you are not so familiar with here, it's a pretty cool ecosystem. I would say that one of the main things that was not true for a long time is the open source mentality. So Starknet started as everything closed sourced. Nowadays we have been, for like, I would say, the past 12 months, seeing a migration towards an open source mentality, where you already have the full node open source. You got promises that both the sequencer and the prover will be open source. But more than this, and I think that we should always take promises with a grain of salt, but I think that the path so far from Starkware has been in a positive trend regarding moving from this closed source mentality into an open source mentality. We also have like a vibrant community of random team members from different teams like us at Finiam contributing to an open source ecosystem, where I would highlight a couple of projects, but you should really like go to the Starware Labs, where we have everything related to Cairo and Starknet, or keep Starknet Strange for more like community focused efforts. And you have something like libraries, a ZK EVM being built by some random people, light clients, full nodes, a sequencer based on Substrate. It's really interesting stuff happening, and I really urge you to like pay attention, because regardless of the tech, it's really a good way for you to learn more about this ecosystem. Some cool projects are being built around this. I would say I would just highlight storage proofs, because I think this is something really unique that is very interesting, where by creating proofs about other blockchains, you have a way to import data from external blockchains from outside of Starknet without actually moving data. So you are just generating proof about an address in Bitcoin at the specific timestamp or a specific block. You can generate a proof by that, and then you can verify that proof on Starknet, and that means that you have access to the information that's or to a very high degree guarantee about information on Bitcoin without actually having to have a bridge or in Ethereum or Polygon or something like that. So I think storage proofs are really something very cool that might have an impact even besides Starknet in the ecosystem in general. Then some other names like games, NFTs, machine learning platforms, Snapshot. I think everybody that's been in a DAO or participated in mechanisms have heard of Snapshot. They are building something on chain with Snapshot X on Starknet, which is pretty cool. And finally, I would like urge you to go and learn a bit more about Starknet and Cairo. It's really interesting technology, and I hope that this brief presentation helped you get a feeling about why it's interesting. Some other people might have different opinions or different things that will captivate them, but I would say that you definitely should check it out just to see if it's something that might vibe with you. You got the Cairo docs and Starknet docs. The Cairo book and Starknet book are also community efforts that have been built for the past 2 months, I would say. Then the Starklinks tutorial, which is also pretty cool. And then this Twitter thread from Odin Free, he is a good person to follow on Twitter if you want to be on top of what's happening on Starknet, where in this specific thread he has a lot of resources about Cairo and Starknet. And finally, I want to thank you for paying attention to me for this brief moment. And then the shield part of this presentation is to talk about Starknet Portugal, a community around Starknet that we are trying to build here. We just had our second event yesterday in this same space, and basically we got the meetup link and the Starknet, the Telegram. If you are around Lisbon, Porto, Braga, Coimbra, please reach out and let's try to make something about Starknet. And even more than Starknet, I think this entire organization about layer 2s is very important, because at the end of the day, what we are all trying to do is to scale Ethereum. So I think it would be very cool to have some kind of Optimism meetup here in Portugal, Polygon. I think it's really, there is a lot of brain power here in Portugal that could be we could create a community around this topic of scaling Ethereum and having different layer 2s interacting with each other, because at the end of the day we are still very small fishes in small ponds, and we should be focused on making this pond bigger and having more people with the know-how and the will to participate in this kind of technology. So I think that's it from my part. Thank you.
Thank you, José. Before we go into a short break, is there anybody that has a burning question for José? Go ahead. Maybe use the mic so you don't have to compete with the people in the back.
Yeah, sure. I mean, I don't know if many people know about it, but what's going on with the sequencer Madara? Do you know anything about it? And maybe if you can weave it into like the L3 vision of Starknet, because that stuff is really cool.
Yeah, so regarding the sequencer situation, I would say that right now you have 3 sequencers being worked on in Starknet. You have the official sequencer that is already used in production by Starknet, and that's still closed sourced. I think it's based in Python, I think, but they have said that they'll be open sourcing that in the next couple of months in the last StarkWare sessions in the beginning of the year. So that's the thing that nowadays is processing transactions on Starknet, and we hopefully will get a look at that sometime later this year. Then Madara is like a community effort. It's basically building a sequencer on the open based on Substrate. And then I think you also have a sequencer, but with the Tendermint consensus being built by Lambda class, also like an open source project. I think that at the end of the day, when we are seeing like these different sequencers appearing in the ecosystem, is exactly about the scaling and the layer 3s. So the idea there is that you can have different choices that your app chain might decide to use different sequencers depending on like your technical decisions, what needs to happen in your specific layer 3, and it's better to have different sequencers that can help you on deciding that than just being stuck with the Starkware sequencer for building everything in layer 3s. I think that at the end of the day, when there is the decentralization process with the sequencer on Starknet, this is something that has been happening on the community forums, where they are talking with the community about how will this road for decentralization happen. They'll eventually select one of these 3 as the official Starknet sequencer, but I think they will all live because of their applicability on layer 3s. I hope that makes sense.
Thank you, sir. All right, everybody. We're going to have a short 10-minute break. Grab some snacks, some drinks. Try to relax your brain a little bit after this content-heavy afternoon, and then we'll get right back into it. But I would like everybody to come back to the front and take a seat. Hey guys, sorry to interrupt. We're gonna get started again. Hey guys, please take a seat. I'll see you later. You're in the panel talk, right?
Yeah, is this the panel now? Or
Tiago?
Tiago, yes.
No, not yet. One more talk, then you're up. Yes. Hey guys, sorry to interrupt, but I would also like to ask you guys to take a seat. Thank you so much. Hey guys, how you doing? So we got one more talk, and to prevent all the speakers to compete with the guys in the back, I would like to ask everybody to take a seat for this last one, yeah? Thanks. Please, go ahead. You guys here for the talk? Sorry? Yeah. Can I ask you to take a seat as well? We got a lot of empty chairs left. We're getting there. All right, we're getting there. Can I ask you guys to take a seat as well? Thank you, sir. You're allowed to bring your snacks into the audience. Thank you. What? You think? I don't think so. I see some last people moving around. Then we'll get started. Thanks all of you who already took a seat. All right. Hey guys, we're gonna get started. Can I ask you guys to take a seat? Thanks. All right. It's amazing what whispering does. All right. Thank you guys for hanging in there with us. We have one more talk for you. Then we got a short panel discussion. And I've just heard that if everybody behaves, we got pizza and beers after that. So please bear with us. And for the people in the back at the bar, I want to ask you guys to keep it down a little bit so we don't have to compete with the echo of the building. Then our next speaker is José. James. Then I'm really sorry, James. Then my info wasn't correct. Our next speaker is James. He works with the PSE Ethereum Foundation. He's going to tell all about it. Please join me.
Excellent, thank you. So, yeah, I'm going to do my best to, hopefully, have you guys understand what I'm talking about. So if the mic drifts too far away from my mouth, just give me a signal and I'll bring it back. And we'll have time for questions at the end. So take any notes throughout. So the project I'm on is, we called it WAX, Wallet Account Experiments. And we've got Team WAX in front of us here. You can give a wave if you like, guys. Yep, so we're all here. First time in a while, actually ever, that we've all been able to be in the same room. So that's awesome. We work within the Privacy and Scaling Exploration Group, which is a group within the Ethereum Foundation that is focused on enhancing Ethereum through cryptographic research. And WAX, when we started, we were focused on BLS Signature aggregation for scaling. So I like to start with the why. kind of standing in front of the text. So it says start with why, which was a Simon Sinek thing. And sort of looking outside of what we do, like why do we do what we do? Why do we care about layer 2s? Why do we care about scaling and lowering the costs of transactions? I sort of draw these, like the x-axis is transaction cost. Obviously at the end we're started there at L1, and when prices go up that kind of limits what kind of applications you can get. So this is kind of intuitive, this isn't database, it's just kind of, obviously as costs go down you get more viable applications that can be built, and if there are, you know, when there's better UX, which is the green line, you can get more users and therefore more impact. So really why we're all here is for impact. So what happened at the beginning? We had, with high L1 fees, you'll get these kind of applications, which you can see over there. DeFi front running, hyped up NFT drops, high value asset transfers. With rollups, or should I not call them rollups now, from that previous talk, if for those who are here. Yeah, I'm scared to say rollups now. Yeah, so with the rollups, you get things like casual gaming. So you can afford to do transactions to buy an asset in a game because the cost has come down a lot. When we get to 4844, that's going to bring it further down. But we sit somewhere here, so we want to bring the cost down a little bit more before 4844 really smashes it out of the park. And yeah, when we do that, when there's lower transactions, we hope to target these kind of applications. As people say, it's the next billion we're all sort of looking to help. So we started with BLS Signature aggregation, and you know, what's that about? What problem does it solve? So at a high level, we've got these, well, at a medium level, we've got these transactions that are applied to an L2, and for each transaction, you have the transaction data and the signature. In this case, you know, ECDSA signatures. When this was originally on Optimism, so it's a bit dated, this diagram, but basically with the call data that gets rolled up to layer 1, it contains everything. It contains all the transaction data and all the signatures of each transaction that was put together and rolled up. So that's a lot of data. So the idea at the beginning was to say, can we reduce that? Can we instead, for every transaction, have one aggregated signature that doesn't lose the ability to verify each one, and therefore roll up less data? So we're only rolling up one signature for all of the transactions rather than n signatures for the n transactions. So that's the problem we're trying to solve with aggregated signatures. But yeah, the way you can look at BLS signatures, I sort of like to draw it as this picture. Basically, rather than put every individual signature in the rollup and therefore pay the L1 cost, BLS lets you, I think it's actually mathematically it's addition, but lets you put together the signatures, aggregates them as one, but also still lets you verify all transactions. So all transactions and the messages that each user signed can be verified by the single aggregated signature. For those who want to peek under the hood, it looks something like this. I got this diagram from there that's hidden. Basically, yeah, each message is signed by each key, and there is one compressed signature that can be verified, and then it does some maths inside that luckily we just black box and use. So basically that's what we're doing. We're using one compressed signature to verify all of the individually signed transactions. So what does this look like? What are the pieces that we put together to yeah, make this work? So we've got a few pieces in different places. This is the original terminology again. This is the prototype extension that has a client module where the transactions are signed by the individuals. We'll first have a dedicated server, but eventually we think this kind of aggregation will occur in nodes. So the individual transactions from different wallets are put together and bundled, and that's where the signature gets aggregated. And then on-chain, which is that last division there, we have the verification gateway contract that will verify that all of the transactions are valid, and then it will go off and execute each one individually. That's within that bundle. Yep, so just a bit of a nod. Did that make sense, more or less? We're going to just go a layer deeper. Yep, got some nods. So yeah, we'll just go a layer deeper. We adopted partway through when 4337 came out, the account abstraction ERC. We adapted our terminology to match that because it was a very similar thing that we were doing. So we have a user operation which consists of multiple actions, so you can then combine multiple actions into one. The wallet was, oh yeah, so different wallets we hoped would integrate this client module, and therefore they would have their users sign with individual BLS signatures. That would then go to the server for aggregation, and we'll go into the next slide there to see where that continues. So then that continues with the compression as well. So we can reduce the data further, which we'll step into as well. So then on-chain you could expand it. do the verification, and then execute against each individual wallet. So that's the flow of how we got there. But I'm going to keep this up here. But because it's a smart contract wallet, the things that were handled at the protocol level, like nonce and take nonce as an example, are now having to be handled at the smart contract level. So the data that is being rolled up or included in this operation includes these wallet parameters that weren't otherwise there in the transaction data, if that makes sense. So transaction data is normally the contract you're targeting, the function you're calling, and the parameters. But now we have to include at that level also the nonce of the wallet and other things there. So yeah, what do we do about that extra data? Thanks to Andrew here. We've got compression. So next slide. Yeah, so I've just basically screenshot his slide, and that's why it's deliberately blurry. It's sort of capturing the complexity of how much data is there. And I say it's not really complex. It's actually just padded with a lot of zeros. If anyone's looked at sort of what gets encoded when you call a function, it is a lot of zeros because it's having the full length of the variable. So the idea is to compress these 640 bytes to something like around 17 per transaction. So there's some, what was it called? Pseudo floating point math that can be done to properly scope the variables. So if you've got a nonce and you have a bundle of transactions and all the nonces are around the same 256, the 256 values, you might basically maybe include an offset or something like that, if you get the gist of that. There's a few different ways that can just go to reducing the data that needs to be sent on chain, therefore reducing what gets rolled up and therefore the cost per transaction. And just a reminder, these are multiple transactions in one bundle, so these are per transaction costs that get saved. Being a smart contract wallet, there are other benefits, and we've seen that more with 4337. They talk about the verification functions that you can, that is generic. Like a wallet will have its own function to check if the signed message for that transaction is valid or not. And that enables us to go further and just have different types of verification. We don't need to be stuck to just ECDSA signatures or BLS signatures. We can do more. So this is from Vitalik's tweet, but linked to the diagram. Still within bounds. Yeah, so we have the flow is different to ours. So in the flow that we had a single verification gateway, which is similar to the entry point, but instead of the verification occurring there, which is how we had it, the verification logic is within each individual wallet. So each individual wallet can have its own way of verifying a transaction. So one wallet might be implementing BLS, another EDDSA or other things. So let's take a look. That's this function here, where it does a check and a pay, which also pays the transaction, but we're focusing on the verification part. And we can just do other things there. We're not limited anymore. And that's what ERC 4337 brings, and that's what our V2 of what we're working on will bring. Will be 4337 compatible. So with all these verification choices, multi-action user operations, like it sounds complicated and there is a lot to consider when you're using them in sophisticated ways. So how do we make this easier to use? Because we can't expect every dApp that wants to use 4337 to have to go on that research task and figuring out the best ways to use it. So we want to put together some examples that make sense. So there might be a mechanism around recovery that requires a multi-call sequence to occur, and everyone could reinvent that wheel themselves, or we could put it together with easier, like we can help these applications integrate what we have with what we're calling the SDK, and it's a node module, and the idea is, again, to just reduce the barriers to dApps, wallets, middleware, SDKs, of using WAX, as we call it. So this is, again, pilfered from another colleague. This is like sort of captures the two key points here. The goal is to keep it simple, using terminology that makes sense, and also having things like sensible defaults. Like we just want to, my focus would be that this can be brought in relatively easily without much configuration and give the dApp the benefit of the components in WAX, be it cheaper transactions through BLS Signature aggregation, or if it's a novel way of recovering their wallet with some ZK proof. We want that just to be easy and accessible to everyone. Yeah, so in summary, we started with BLS Signature aggregation for layer 2 savings. We're continuing to be ERC 4337 compatible with additional verification choices, and again, wrapping that all up in the SDK to make it easier for everyone to use. And this is us. We are WAX. We're inside the privacy scaling explorations team of the Ethereum Foundation. And yeah, let's hear any questions. Thank you.
Thank you, James. Do we have any questions before we move on to the panel discussion? We got some time, yes, sir. Wait, let me hand over this mic.
Yeah, so I was just wondering how this is all focused on layer 1 scaling, for layer 2 scaling to layer 1 and accommodating for it. So what about the plans to make layer 1 scale by itself on its own?
Yeah, the initial project was given to us with a specific focus, and it was to reduce the costs of layer 2 transactions. So we came in at the point of saying, when you roll up data with an EVM rollup, there's an amount of data that is going there, and can we use BLS Signature aggregation to reduce that? That was literally where we began, and that was our focus. So we didn't quite ourselves explore what could we do on L1 and do something else other than that, because that's where we began. We've sort of, the scope of what we've done has increased, but more so in the direction of 4337 and additional verification methods. So maybe we didn't quite do what you're asking, I don't think. Yeah. Yeah. Okay. Yep. So another one.
What additional privacy are you going to offer with this? Obviously, with 4337. Also, if you compare it to attempts like Mimblewimble to sort of do range proofs and obviously hide balances and so on, does that get you down the route of causing issues like privacy-wise? And what is your vision around this? Like, what do you want to happen? Is this just like a base SDK layer, or are you actually have you got an aim? What's your vision for?
Yeah. So. Yeah, again, the initial focus was the cheaper transactions, and then these additional verification methods can introduce, I guess, more, the ability to preserve privacy more than that, because at the moment, it's an off-chain signature, and that key doesn't have to be, have an associated address with it. Obviously, when a smart contract wallet sets a certain BLS public key as its owner, if you will, it then has that link. But in terms of preserving the privacy, we do things like with the recovery mechanisms where we conceal who can recover a wallet by just storing, say, a hash and a salt on chain. The hash on chain, and then you'll need then the salt and then the caller to be able to recover it. So we have, in certain places, I guess, we're considering that. We're not doing full private transactions. That's not within the scope of what we're doing at the moment. But I feel maybe with some of the verification methods that we're getting to, we will be able to address more of these privacy concerns, but it's not our focus right now. Yeah.
Thank you, James.
Excellent, thank you.
Then for the final activity of tonight, apart from the party, of course, we got a short panel discussion. While Alex is putting the poofs on stage, I would like to address everybody in the back. Guys, can I have your attention for a second? I'm getting some notes from the audience that it's really hard to hear what's going on here. So I want to ask you guys for the last 30 minutes of today, to please keep it down. Thanks. Yeah, like that. Perfect. Then I would like to invite Dominik back on stage. Where are you? There you are. And Dominik will be hosting our panel talk together with, need to grab my paper, my RAM memory only goes so far, Emily Lin does DevRel at Linea by ConsenSys. Then we got Tiago Barbosa, the CEO of StarkExpress and 3 Sigma. Then we have Raza. There you are. DevRel at Scroll. And last but not least, my dear colleague Max, who does BD at Cartesi. So Dominik, you got a mic. Unfortunately, I only have one extra mic, but since Web3 is all about community and sharing, I assume you guys won't have a problem with that. So I'll start with you.
Nice.
All right.
Hello.
Hello.
Maybe we can start with a short intro of each of you, and why would I, as a developer, choose your rollup?
Cool. Yeah. As Claudio just said, I do BD at Cartesi. So we're slightly different from other rollups. We are application specific. So as a developer, you would choose us if you want, more computational power. The second thing is that we're non-EVM. So we run on top of EVM chains. We run on top of Ethereum. Could run as a layer 3 as well on top of other rollups. But we have a custom VM based on RISC-V, and that allows us to put a full Linux operating system on top of it, and basically, use traditional programming languages, complex libraries, and existing tooling from Web2 to build your dApps.
Hi everyone, I'm Raza. I'm a DevRel at Scroll. Scroll is a ZK rollup. I guess there are a bunch of ZK rollups popping up, and the reason why you would choose Scroll, I think mainly I guess from two angles. One is that from a principle and company point of view, we try to stick very close to the Ethereum principles. So our community and brand is very, very strong. Right now, if you look at the ZK space, I'm really glad that the respect that our ZK research and engineers get is strong community vibes. And on the other hand, I guess the underlying tech. Right now, we're focusing hard as being really maximizing the compatibility. I think most people would understand the types that Vitalik pointed out, and described. Really, because we see the added value of being close to the Ethereum ecosystem and the developer experience. I often say, as a developer, the reason why you like or love or hate a product is you just play around different tech protocols and it's death by 5,000 cuts. It's the getting started page that's not good, or is the tech that just doesn't work as promised. So delivering on those basics in value, I really believe that Scroll will have a distinguishing factor.
Hello everyone, I'm the CEO at StarkExpress and 3 Sigma. My name is Tiago. So the reason why we chose to build on StarkExpress as a layer 2 is because we're abstracting everything that is complicated about blockchain technology. So you don't need to learn about ConsenSys algorithms, smart contracts, cryptography. Everything is abstracted and you build only using Web2 APIs. So you could use the programming languages that everyone is already very familiar with, coming from a Web2 background, and still for the end users of applications who are built on top of StarkExpress. You also don't have gas markets, you have Web2 latency, you can have private transactions, it has very high TPS. So if you are already an existing Web2 business that has Web2 users, you can pretty much do the transition to blockchain technology, and the end user would never understand that there was the transition and now you have digital assets and they are working with the security of Ethereum. The reason why we believe that is extremely important also is, well, everyone is competing for the same pool of Web3 developers. Everyone that's on this room probably is very technical. They understand all of the intricacies of blockchain technology, but if you really want mass adoption to come to blockchain, we actually need to start talking with people that don't understand all of the different parts. Now everyone is even talking about the modular stack. For us, we understand all of these different components, but it's very important if people actually don't need to understand any of them to interact with our technology and come play in the Web3 world.
Cool. So hi, I'm Emily. I'm with Linea. Before I dive into it, I know Raza mentioned, all of you are familiar with ZK EVMs, the different types. Is that true? Okay, so the majority of the audience actually doesn't know the different types of ZK EVMs, which I think is actually very important when talking about, the differences between the ZK rollups. So I'll just cover this really fast. So type 4 you can think of as high-level equivalent, so you can write in Solidity, but that compiles to a different VM, to a different bytecode. So your tools have to change. So that's going to be something like Starknet, ZK Sync. They are not bytecode compatible. As you move closer to 1, so 1 is Ethereum equivalent. Type 2 is where Linea is going. So that's, you can write in Solidity. We are also going for bytecode equivalent, so literally nothing changes, right? So I guess for Scroll and Linea, when we talk about being very close to the EVM or Ethereum, right, that's constantly changing. We are able to kind of adapt the fastest to that, as well as your tooling doesn't change, right? There's a really strong use case for network effects. So if you write in a different language, right, you have to find a whole new set of auditors who need to learn how to do that. There's a bunch of education out there already with regards to Solidity, finding and developing an entirely new community, really difficult. And then when you dive into Linea itself, so let's forget about the tech part, let's focus on the users, right? We live within the ConsenSys ecosystem, so there's native integrations with MetaMask, which you guys all probably have. But also, right, Infura, our clients, Teku, Bezu, all of that. So again, pushing that network effect part is Linea.
Thanks. And as we can see, the L2 space gets super crowded, right? So there are many different L2s, many different designs, some are super similar. What must a project bring, basically, to survive? What do you think? What would be the 2 key parts? And try to keep it short.
The 2 key parts? Okay, community and collaboration. Should I expand, or is that short enough?
That's okay. Does someone want to respond?
Yeah. I think different L2 designs bring different value propositions and they have different problems. So there's a lot of competition, for example, on the ZK VM side. Then on different virtual machines, you can talk, for example, about Polygon Miden and Starknet. Probably are the ones that are competing the most in this angle. Then we also have optimistic rollups like Cartesi doing more complex things like Linux operating systems. You could also talk about Risk Zero and Bonsai. All of them, I would say, have different targets of audience, have different value propositions and places that they're trying to find in the market. I think, bottom line, if you want your project to survive, it would be very interesting if you could abstract it all away. Of course, it might be a biased opinion because that's exactly what we're doing at StarkExpress. But at the end of the day, if the barriers to entry for both the users and the developers are too high, I think it's going to be very hard to continue competing in this ever-evolving space.
Yeah, I guess my answer, the easy one, is a combination of what was mentioned both. I think community is very, very important. It's very important to Scroll as who we are. But generally speaking, I guess for L2s, I 100% agree. I think that there will be different needs. I think there will be subtle but important differences when it comes to maybe gas fees or compatibility or interoperability. So I think that is what you're seeing right now in the ZK, especially in the ZK tech space. We're not done yet. So we're still developing, and you're going to see this. You're going to see design choices that make a difference for, especially the developer, but also the end user. And even though we try to optimize, like Emily said, for the type 2, thanks for explaining that. By the way, no one raised their hands for the MetaMask question, but to try to optimize, for the developer experience. So I think that there will be, like you mentioned, I think it's a key factor. I think different needs for developer and end users will dictate the development of L2s and potentially who will survive.
Yeah, not much to add. Indeed, a lot of trade-offs. There's always trade-offs, especially on the tech side. And there's no one-size-fits-all. So depending on your requirements, there's a bunch of different options. And that's really cool. And indeed, community plays a big role as well. So again, there's not one-size-fits-all. Maybe there's certain communities that are better fit for you.
Cool. Yeah, why do you think that Arbitrum leads the L2 space by such a margin?
In terms of TVL?
Yes.
Yeah.
Or economic activity, as Linea would say.
Yeah, I guess I would say they were quite early to market, and they have a pretty strong DeFi community. And DeFi is sort of the main, like the most established, mature use case for blockchain right now.
Yeah, just to add on top of that, I think that one thing that Arbitrum did really well is the dev experience as well. As far as I've played with it, and then I've spoken to some of my DevRel colleagues, it's just that deploying was seamless. It just worked. And like I mentioned, why I believe that, not to show, but when I did my intro for Scroll, I said, as a developer, we all, like, for those who are developers, know the pain, death by 5,000 cuts, because it's like, and this is not working, is that not working? Anyone playing with AI models right now, it's, any repo you see is just pip install requirements. Pip install my ass. It's not like you just use it and then it just works. You need to tinker with it. And I just think that what Arbitrum did really well is that the dev experience was as promised and delivered. That's what I would say.
Yeah, I do think that probably the reason why Arbitrum has taken the lead is not only on the technical side. So unfortunately, like, we are still a very immature industry per se. We see all of the TVL like basically going around the same chains. It's always the same users, the same money, like, just like floating. And of course, the economic factors, such as, for example, like airdrops and everything else, also pretty much helps with getting more attention on the chain. That's also, for example, you can consider it to be also the reason why, for example, ZK Sync has gained more adoption than Polygon ZK VM, even though on the technical level it can be discussed which one is better. But on the adoption side, I mean, ZK Sync still doesn't have a token. Polygon has Matic out, so people look at it, and between the two options, well, maybe I will go to ZK Sync and risk getting an airdrop. So I think that's probably the factor that influences the most. The second one, a little bit more on the technical side. So if you're looking at scaling solutions, you should also try and build new DeFi primitives that take advantage of the solutions. An example could be like, you couldn't have GMX running on Ethereum, but you can have Uniswap v2 running on Ethereum as well. So if your chain is only like working with protocols that were built because of Ethereum's design and like its limitations, like probably it will not bring as much adoption as if you're going to like start working on new DeFi primitives. Like, well, I wouldn't say it's like a new DeFi primitive, but at least new implementation details on a protocol like GMX that brings a lot of user activity, a lot of liquidity, and new use cases to your ecosystem.
Yeah, I feel like I agree. Maybe my hot take here is a Rollup is successful because of its users, not because of its developers. Oh, okay. Also because of a developer experience kind of thing, but it's kind of a chicken and egg. For Arbitrum specifically, you asked this question, so you just go on DeFi Llama. It is GMX. They're like driving all of the liquidity in like the TVL, right? So when we think about like rollups and being successful, it becomes, what is the killer dApp that's going to attract the most users and attract liquidity? And once that's there, then that is also incentivizing developers and builders and entrepreneurs to say, hey, there's a lot of opportunity here because all of these users have already onboarded into this ecosystem. And so Arbitrum, I think, got really lucky with GMX as well as just being the first. Especially, it's really key for, I think, rollups to be on mainnet early. Because something for like a DeFi app, right? When we're like onboard onto Linea, they're like, why? You're only on testnet. You're not making me any money, right? So I'm not going to actually onboard until you're in mainnet. So it's a combination of dev experience, apps that are there, and also kind of whether or not you're on mainnet, testnet, and obviously the airdrop. Like that definitely drives. Yeah.
Sorry, yeah, just like I do think that the airdrop is a pretty decisive motive because GMX is also live on Avalanche, for example, and you could also have the same user experience in Avalanche. But people just decided to use it in Arbitrum because, hey, maybe the Arbitrum token will be airdropped, and in the end, at the end of the day, it was.
Yeah. When we talk about airdrops, that could be interesting and might be a controversial question. Why does an L2, especially a ZK EVM, need their own token?
I feel like I'm not allowed to say anything on this topic because that's like, oh, we're thinking about it, but not necessarily, right? But I mean, in terms of like whether or not you need a token, I don't think you actually do, right? You can get money through like fees and all of that. I think tokens are really good for like incentivizing dApps maybe to build, used as governance. There are use cases for it, but I think at least like Linea, that's not our focus right now, right? When we, if that happens, like I think tokenomics is a really important thing you have to think about, but like just to willy-nilly say I'm gonna have a token is actually a very, I think, controversial thing to say, because you don't want to accept just like people who are farmers, right? That's not gonna create like long-term use. I don't know if that answered the question, but
definitely.
So will there be a token? Hopefully. But with regards to like should an L2 have a token, I think it depends on its decentralization goals. If you want to decentralize your sequencer and your prover, I think it's quite hard if you don't have a token of yourself to create like a network effect for people to actually enter these networks. Of course, there's a lot of discussion, for example, around eigenlayer and, for example, using restake ETH to use it. But people who restake ETH, they actually need to get rewards. That's part of how eigenlayer works. And if you don't have a native token for your L2, I'm not exactly sure how you're actually going to be incentivizing people to restake ETH for your own sequencer. So at the end of the day, I think this is still like a big open question, because if you have a token to decentralize, or if you use restake ETH, you might say, okay, we don't want to continue using the token, but for us to have restake ETH, we actually need the token, because at least we need to provide some economic incentive to people who are restaking ETH. But at the same time, if people are buying my token, then they're just getting diluted, because the people who are restaking ETH, like I'm going to print more of my own token to give it to them. So I'm not sure where the economic incentive would align. Right now, I do believe that L2s will continue having their own token to decentralize the parts of the sequencer and the prover. Because, for example, in Arbitrum's case, I mean, you use Ethereum for the gas, you don't use the Arbitrum token. If you just go and restake ETH to decentralize the rest of the components, I mean, what is the Arbitrum token for? Just to incentivize people to restake ETH? Like, there's no sink in value. So at the moment, yes, I would say that L2s will continue having their own tokens, having control over their monetary policies, instead of decentralizing with other tokens.
I mean, I don't need to add much to what was said, but I will say, so the question, do you need L2s? Do they need a token? No. And I think the things that have already been mentioned, I think the main thing, and I'll just summarize it because I think it's all been said, I find it very difficult to find the economic incentive, and it feels like it's more reasoning towards having a token rather than that there is a problem that we solve with having a token.
Just as a question that you can answer in addition, but could it be that the token incentive for L2 is from the old world, where we had different side chains that needed to be secured by proof of stake? And can it be that for L2s we need a different model, not a token model, to also to get money or to incentivize users?
I'm not sure, because like I said, I think the ZK rollup space has a entirely different architecture than POS. So there are loads of things that we need to revisit. So I do think that these questions are being asked behind closed doors for every ZK rollup. Why token? And I think we know the answer, when this is done. But like I said, I wouldn't. Yeah, it is something from the old world, yes. But again, it comes back to, do you need it? And then, why? That I have difficulties answering that question.
Thanks.
Yeah, so we're not ZK, and we do have a token. I think, I agree with everything. I don't think you necessarily need a token either. But I do think it could play a big role in governance and aligning incentives within the community, and then obviously things like slashing, rewarding behavior to maintain security. Obviously, you could use other tokens as well to do that, like ETH. But yeah.
I do think that if we move into common infrastructure such as shared sequencers and solutions like Espresso systems, you could end up not requiring a token, but still at the time, it's like you said, I really believe that the economic incentive is more aligned towards every L2 issuing their own token.
Got it. And do you think that maybe in 1 year or in 2 years, L2s will somehow converge, like using a shared sequencer or using and a ZK tag the same field, or maybe a common prover, or using something to establish interoperability? or will we have these silos of L2s that operate independently?
Well, if Tech Twitter is saying anything, it seems like we're very far away from that. And so I think there are multiple elements to if that potentially would happen. I think on the technical level, as I said, ZK tech is maturing. So that's like on the technical side of things a bit far away. But I think that what we're noticing right now in Web3 as well is loads of people came because of the ethos and the principles. But at the end of the day, we also see companies. So I think that if there's an aligned incentive model, I don't know, like I haven't thought enough about it, but what that would look like, I guess it's a possibility. And at the end of the day, if it would benefit the end user in such a way, and then all parties involved benefit as well, then I can see it moving towards that for sure. But then again, on a technical level, there's a thing. So on the short term, I just find it difficult to envision what that would look like.
Yeah, I think one part of the question I'd like to answer is like the ZK versus optimistic rollup question. I think a lot of use cases we see on Ethereum today will be kind of gobbled up by ZK rollups. But you know, there will always be needs for more compute, and you know, proving costs are quite expensive and will probably remain expensive, even if they will drop eventually, or at least they will be cheaper still to do it on optimistic rollup. So there's not like one solution fits all, and I think depending on your needs, again, you might opt for one or the other. Yeah. Oh yeah, and I think interoperability is a bit overrated as well. Like not everything needs to be perfectly composable. Like in some use for some use cases, like asset composability at like the base layer is sufficient.
So I do believe that a lot of the advancements that we see on the ecosystem are pretty much dictated by the collective mindset of venture capitals and where they direct capital for things to be built. And we see a lot of capital being directed towards interoperability, bridges, solutions like Succinct Labs, Polymer. And at the end of the day, I do believe that the entities that control the flow of value, the capital, they do benefit from having like a shared ecosystem, shared liquidity. So I believe that they will continue funding these projects, and at the end of the day, like the blockchain ecosystem will evolve into a common set of rails where capital flows in a much more free way per se. So yeah, I do believe that eventually things will keep converging. That's also part of the reason why we're building a solution that abstracts it all the way, because as the ecosystem evolves, we are positioned in a way of like, we already solved the abstraction, we already know how to simplify the things for the users and for the developers, and then we can continue like working in our niche technology world, keep iterating things on the back end, improving bridge solutions, interoperability solutions, but we already have fixed basically like the bridge into outside Web3.
Cool. So to answer your question, in 1 to 2 years, I have no clue. I'm not that smart. But to the question of will we all converge on a decentralized sequencer, for example, absolutely. I think that is a single point of failure. We cannot be there. When we talk about like converging maybe provers, who in the audience has heard of like the multi-prover theory? Oh, okay, nobody. Very cool. So basically what that states is, okay, all of our ZK rollups, right, have a prover. Our provers are our own tech. There is a possibility that there's going to be a bug, right? So if everything is going through our own prover, no, right? So multi-prover is basically saying like, hey, you can take all these transactions, feed it through each of our different provers, right? So Scroll, Polygon ZK, VM, Linea, or something like that. And you get this like composable layer of like, hey, we need a consensus to say this is correct. So even if Linea has a bug, and Scroll does not, then maybe Scroll will say, this is true. I'll say it's true, you say it's false, and then, wow, okay, that's amazing. You know, and that's something we need, and I think is critical to the, you know, success of the L2 space. But yeah.
Cool. Wouldn't that be converging into like an optimistic model of ZK rollups? Like it looks like if we're basically it's pretty much like everyone is proving the same transactions. Some say like are correct, like you reach different states, then you would need like some slashing mechanism, and it looks like a little bit like falling back into an optimistic path on ZK rollups. And I also believe that yes, I agree with you on like the timeline of 1 to 2 years. But once we start like formally verifying circuits, I do believe that these problems will eventually evaporate, or at least I hope so.
Yeah, I guess to the point of like optimistic ZK rollups, I don't know, that's an interesting way of phrasing it. I don't think that's necessarily a bad thing. I think when we think about like optimistic versus ZK rollups, we're talking more about like the existence of that challenge period to wait for 7 days to withdraw because of the fraud proofs. The reason ZK rollups are winning right now, right, is validity proofs. Like they're not the fastest, they are much faster than 7 days, right? I think as prover technology improves, we get faster and faster. Like that's kind of the problem of optimistic that it solves, right? So optimistic ZK isn't a bad thing, right? Yeah, so.
Yeah, in a way, it could look like this if you have several provers and you need consensus. Then, yeah. Cool. Yeah, maybe a last question. Imagine we have we have solved the scaling problem. Like we're trying to scale Ethereum now since 7 years or so, right? So imagine that rollups are the thing now, and there's not coming something else. What else, like if we don't think about scaling, what else would we tackle next?
Yeah, so I guess like it always just comes back down to use case, right? So once the experience is as smooth as possible, you need to onboard users because they want to be there. Like, I honestly, like, DeFi is such a small segment of the population, or just like financial stuff in general. I'm gonna out myself, like, I only really invest in the S&P 500, right? So like, I'm very, don't include, okay, I do have some stuff in like crypto, obviously, but I'm saying like 100 million users are not going to be like, you know, all in on token and stuff like that, right? So, I mean, in terms of what I guess L2s can do in like with regards to onboarding, say we've solved the scaling problem, then we're starting to focus on, hey, we've developed these really vibrant ecosystems. How do we incubate that community? How do we fund the correct projects? And I don't know, like support them. Ultimately, we're like infrastructure, right? So I don't think scaling Ethereum will ever be. Things can always be made faster. I'm going to say that.
Yeah, I agree with you 100%. I do think that for prioritization of these use cases, we should get more feedback from the market. But up until now, the user experience is so bad for anything that's Web3 that's even hard to get feedback from the market. Like if you get everyone from your city to tell them, okay, what you would like to see being built with the capabilities of like a decentralized ledger, they'll say like, what the fuck are you talking about? I do think that it will take a while, but definitely more use cases, better user experience, more users in general, understanding exactly like on the human scale, on the society scale, what is exactly blockchain good for? Because up until now, that's completely a question mark.
Yeah, that last point was actually the point I was going to make, is that I really think that what's going to happen, like I think the cool thing about the AI storm is that a lot of people, at least like in my environment, that are like completely disconnected from, let's say, tech, like my friends who are maybe a logistic company, like are looking at tech saying, whoa, tech is advancing a lot. And we kind of didn't manage to do that with blockchain other than crypto scams, you know, FTX is happening. And when I explain to them what zero knowledge could do for them from a decentralized identity point of view, or even scaling in, like they're smart people and they can have an appreciation for it. Maybe to out myself, like Emily did, I definitely have like, you know, an investment portfolio, a significant proportion in crypto, but I'm not too sure about the convergence, for instance, on the low level, on the infrastructure level, whether that's sequencer or the multi-prover theory. The reason being is because I see these separate teams working extremely, extremely hard on their own tech. And like I said, like I answered in the previous question, I see them have subtle differences. And on these subtle differences, they'll serve different purposes. So what's next? I definitely don't think we should innovate to innovate. But what I do think is going to happen is that I see a rise of L3 happening. and I can see another layer existing where there is no convergence of sequencer or a multi-prover, but there is really separate worlds. And maybe that is kind of a multi-prover, like a different layer that does that. But I'm not sure about the 1 to 2 years, and I'm also not sure about the convergence, because the world I see today is, from my point of view, is very, very far from it. And maybe not even so on a technical level, but when it comes to, let's say, the cooperation in space, I mean, you rightfully mentioned the narrative of VC money, for instance. Like, I would say that's a huge obstacle. So I think that looking at where there's to innovate, I think these problems will be solved. The technical limitations, for instance, on decentralization of sequencer, or the security of the proof node and the accuracy of the proof node, but through different means. Where that's gonna happen, I can't see yet, because I'm like Emmy, I'm also not so smart. But I'm curious to see what's gonna happen.
Yeah, I agree with everything that was said. I think a big thing is, like, I don't think maybe we'll solve scaling, but like we'll always want more scale. Like, we always want more complex, like, to do more complex things, basically. So I think that will be like a never-ending problem. Or not problem, but something that we will always strive to like improve. I also think we could see more experimentation at like layer 3, and like to plug Cartesi a bit, like I think we can do, like, it kind of opens, like layer 3 opens up kind of the design space for execution. So you could have very different types of VMs and stuff like that, and do also stuff like Tiago is doing with StarkExpress, kind of abstraction layers that open up the space to a lot more developers, which again is a chicken and egg problem. You need users, and we need applications that actually need this tech. But yeah, I don't know. I'm curious to see what will happen.
Cool. Thanks a lot. I think that's it.
All right, everybody. Before we go get some pizza and beers, Dominik, thanks for hosting. Great questions. I want to thank all of you for being so quiet. No, let's give that a round of applause. It almost scared me. And to finish off the list, I would like to thank Epic Web3, Alex and Ollie for hosting this amazing day. I hope you all got what you came for. Now let's get some pizza.